Hare Krishna, Hare Krishna, Krishna Krishna. Hare Hare, Hare Ram, Hare Ram, Hare Hare. Hello, are you able to hear me? Are you able to see me and hear me? I'm not able to see you. Hello everyone. Are you able to see me? Arey, I was waiting here. I was in front of the screen for last 15 minutes, but I was not able to see you. I'm not late. हाँ exactly LRDI में numbers ये भी एक issue था. Okay, anyway. So how are you? Exactly LRDI marathon का thumbnail है. कुछ तो गड़बड़ हो गया है. Anyway. So finally we are here. Okay, so yes, should we revise number system before this class or we can go ahead with this? Certainly we can go ahead with this. We are to go now together. Yes, I'm audible. Thank you for that, Ankit. Some issue was there, Keshav. Right, true. Anyway, let's start now. So I hope the screen is completely visible. I'm perfectly fine, Raghavendra. Is it possible to score 100% in 3 months? Why not, Rish? Why not? It depends upon your present level. If you are presently very nice, very good, so 3 months is a sufficient time to brush up. But if our basics are not very clear, then certainly it is going to take time. Okay, let's revise quickly. So in numbers, please quickly tell me what different topics have we discussed? Whether you have been an iQuanta student or you have been a student of some other institute, some other classes, or you are preparing on your own. So what different topics are there in numbers? Please quickly tell me. I'm going to write them down here. What are the different topics in numbers topic? Fast, please. See, this chat is the only media through which I can connect you. Fine? I can't see you. Am I visible? Oh, yes, LCM, HCF, remainders, factors. Okay, let me write factors, LCM, HCF, remainders. What else? Percentage is not a topic of numbers, Rohit. Yes, unit digit, tens digit, you can say divisibility rules. That's a good point. Divisibility rules. Unit digit, last two digit. That's a subtopic of remainders only. Permutation combination is not a topic of maths. It's not numbers. Fine, these are the basic topics, right? Other than this, yes, classification of numbers, right? Classification of numbers, basically different types of numbers. Fine, different types of numbers. Yes, cyclicity is also part of that. Anything else other than this? Yes, factors, remainders, that's fine. Factors is there, remainders is there. Factorials. Factorials was also a good topic here. Right? Isn't it? Factorials, we discussed many things about factorials, right? Yes, trailing zeros and powers of certain numbers. All these things are there. Okay, okay. Anything else? Yes, Fermat's theorem will be there in the remainders only. Fine. So these are the major topics. Any other topic? Do you recall? Yes, these are the major broad topics here. Yes, CRT is a part of that remainders only. There are different remainder theorems. Chinese remainder theorem. Okay. Okay, let's start now. Let's start. So there are some questions in numbers topic which may not be which cannot be categorized in any of these. There are many questions in CAT which appear in CAT which cannot be categorized in any of these. There are many such questions. So basic point is that when you see a question of numbers in exam, you may not relate with it sometimes. You may not relate it. अरे भाई ये तो factors तो पूछा नहीं इसमें, remainders नहीं पूछा, divisibility नहीं पूछा, something else is there. So how to deal with those things? So for that purpose, you need to be always thoughtful, always ready with the new thinking skills. How to think totally new thing. ठीक है? So we are going to revise all the things. We are going to discuss all the questions on these topics and as well as some other topics as well. ठीक है ना? So what you know, that is going to be revised today in a fast manner, and also what you don't know, some new things will also be covered today. Is it okay? Fine. Okay, so are you ready for the first problem? I'm going to give you problems quickly and then along with that we are going to learn. Fine, ready? Okay, yes. So here is the first problem for all of you. Please have a look on it and answer. Let me just mention it. It is 1A, B, C, D, 7. 1, 2, 3, 4, 5, 6. So this is a 6-digit number. It is multiplied with 3 and the result is another 6-digit number formed by the same digits. A, B, C, D, 7, 1. Now question is find the value of A plus B plus C plus D. Nominal, don't get trapped in the advertisement. You can skip it. Certainly, Brownie, if you haven't done anything yet, so at least you are going to have a glimpse of numbers, isn't it? So, Kalyan, we are going to discuss Fermat and remainder, Fermat theorem and Chinese remainder theorem also. Don't worry. Sunil, certainly. I have already answered that. If your basics are clear, if your basics are good enough, then certainly you have sufficient time. Okay, I'm getting answers here. Sakshi, Danny, Abhiram, Sunil, Keshav, Nidhi, Sara, everyone is giving same answer so far. Okay, good. Danny has explained the complete, has written the complete number as well. Nice. Yes, 19 is the correct answer. Okay, please quickly tell me how to start this question. How to think about it. See, this question we can't categorize in any of the earlier categories, right? It is not a topic of, not a question of divisibility in a way we can say, or although we are multiplying it, so somehow this number is divisible by 3 we can say, but directly there is no formula associated with this. It's good, it's good. If you are able to understand fast, that's a good thing, na? See, one should be a good learner. So the moment you have decided I need to go for CAT or something, so start learning, that's it. Now you are to gauge yourself. If you take time, then give yourself enough time so that you can prepare nicely. But there is no need to hurry. There is no need to go in rush. Okay, how to answer this? Any idea, any suggestion here? Fast please. Many of you have got the right answer. Okay, Navanil is saying A should be 2. Why do you think so? A should be 2 so that multiply by 3 करके 1 आए तो 7 होगा. Okay. What else? Anything else? Aniket says D plus 2 is 7. That's a good thing, but D plus 2 nahi, it is 3D plus 2. It would be 3D plus 2, Aniket, isn't it? Yes, logic se ho jayega, exactly, Shreyan. Danny is writing the complete expression. That's very nice again. 2 shift करके 142857 को 4287 आया है. Exactly, that is true. That is true. That's a good point. Aditya is mentioning about unit digit. Yes, divisibility rule of 3. Okay, let's see now. There can be various ways to answer this question. Let's do with simple multiplication. So the given number is 1, A, B, C, D, 7, and it is to be multiplied with 3. ठीक है ना? And given is the result, which is A, B, C, D, 7, 1. Fine. Okay, let's do the normal multiplication only. ठीक है? So let's do the normal multiplication. So 3 when multiplied with 7 is 21, isn't it? So 3 times 7 is 21. So 21 ka 1 and 2 is carry. So I'm putting the carry 2 here at the top. Fine, so this 2 needs to be added further. Is it fine so far? Next step. Now tell me 3 into D, that is 3D plus 2 must end in 7, as somebody was mentioning also. Isn't it? Now tell me 3 into D plus 2 should end in 7. What can be the value of D here? What can be the value of D here so that 3 को D से multiply करने के बाद if I add 2, it should end in 7. Please think and tell me the answer fast. What should be the value of D? Yes, it should be 5. Can it be anything else? By the way, Ashish is saying 5, Nidhi also. So that satisfies, na? 3 into 5, 15. Plus 2 will end in 7. That's fine. Can there be some other value of D also? Is there some other value possible for D? No. We can easily check now. If I put D equals to 1, so 3 into 1, 3 plus 2 doesn't end in 7. If I take D to be 2, so 3 into 2, 6. 6 plus 2 does not end in 7. If I take D to be 3, so 3 3s are 9. 9 plus 2 also doesn't end in 7. 3 into 4, 12 plus 2 doesn't end in 7. 3 into 5, 15 plus 2, 17. That ends in 7. 5 satisfies. What about 6? 3 into 6, 18. 18 plus 2 ends in 0. Does not satisfy. 3 into 7, 21 plus 2 does not end in 7. 3 into 8, 24 plus 2, 26 does not end in 7. 3 into 9, 27 plus 2 does not end in 7. Confirmed. Confirmed. D की value 5 ही हो सकती है. Is it okay? Prashant, we have checked all the values. I have checked all the numbers. Isn't it? So it is certain that D has to be 5. Does everyone agree? Fine. So 3 into 5, 15 plus 2, 17. 17 ka 7 and 1 carry. Is it okay so far? What is the next step now? Yes, it is not mentioned. Although, see, generally different letters refer to different digits, but it is not mentioned here clearly. That's why I am checking all the values. Is it okay, UV? Normally, the different alphabets should refer to different digits, but it was not clearly mentioned here. That's why I'm checking the possibilities. Okay, let's move further. So, that's fine so far. 3 into 5, 15, plus 2, 17, 7 and 1 carry. Okay, what is the value of D here? Do we know? This D is same, 5, isn't it? Same letters certainly refer to same digits. Fine. So this A equals to A, this B is same as B, this C is same as C, and this D is same as D. So this D is certainly 5. Now going by the same method again, 3 को किससे multiply करूं so that after adding 1 it ends in 5. What should be the value of C? Please quickly tell me. 3 into C. What should be the value of C so that 3 into C plus 1 ends in 5? Yes, C should be 8. Good. So 3 into 8, 24 plus 1, 25, right? So 5, now carry is 2. Now what is the value of C? 8. So this C is also 8. Same way, let's proceed further quickly. 3 को किससे multiply करूं so that after adding 2 I get 8? What should be the value of B? 3 into 2 makes it 6, right? So 6, 3 into 2, 6 plus 2, that is 8. So it confirms that B must be 2. See, there is no carry this time because 3 into 2, 6 plus 2, 8. There is no carry, right? Now, A should be such a number that 3 into A ends in 2. सोच के बताओ, what can be the value of A so that 3 into A ends in 2? What is the value of A? It should be 4, isn't it? So 3 into 4 ends in 2. 3 into 4 is 12. So 3 into 4 is 12. 12 ka 2 and 1 carry. Now this A is 4, so this A must also be 4. And let's verify the last step. So 3 into 1, 3 plus 1, 4. It matches. Fine. So this is the right answer. 142,857 multiplied with 3, that gives you 428,571. Is it fine? And it's a previous CAT question, slightly made easier. It's a previous CAT question only, slightly made easier. In the actual CAT question, this 7 was not given there. This 7 was not given there. Although it is very easy to identify. You know that 3 को 7 से multiply करने पे ही 1 आएगा, है ना? So in actual CAT question, this 7 was not mentioned. That is the only difference. Is it okay? अखिल जैन, A आ गया ना? 3 को किससे multiply करोगे so that you get 2? It's 4 only, isn't it? Because 3 into 4 ends in 3 into 4 is 12. Fine? Yes, it is a logical question. That's what I mentioned, Ritika. So this is a question on numbers, but you cannot classify this question in any of the categories which we have listed earlier. Okay, any other way to think about the same question? Any other way? Is there any other number which follows this type of cycle? No, Danny. No. By the way, I don't know whether you people have observed it or not, but Danny has mentioned the complete cycle of this number. This is a special number actually, 142857. Let me write it in circle. It is also known as cyclic number or circular number, 142857. So it is a cyclic number. If you multiply 142857 with 2, please check what do you get. Please check. If you multiply this number with 2, please everyone multiply this and see what do you get. Yes, it is a fraction of 1 by 7 exactly. Yes, Rish, I am going to come that any other way of doing it. But let's first multiply this, see what you get here. Some people have done it already, but many are there who may not have done. If you multiply, what do you get? Please multiply fast. Yes, thank you, Shaurya. It is 285714. Good. 285714. See, I had written these numbers 142857 in order here. Now, if you see this answer 285714, you can also locate this in the same cycle. It's starting from here 285714 in the same order, right? Same way, if you multiply this number with 3, again you will find the answer in same circle, in same order. So this is a special number. It is known as cyclic number. And Danny was asking, is there any other number? Answer is no. So 1 by 7, it is a fraction of basically 1 by 7. So 1 by 7 when written in decimal form, it is 0.142857 bar, because this cycle is repeated. Okay? Okay, coming back to the same question. Any other way to think about this solution? How to solve this question? Although this is also easy way, this is not difficult. Any other way to think? Now let's see. Please listen carefully. If I consider this ABCD, this 4-digit number, as a single entity, let's take it as a single entity. ठीक है, मैं इसको क्या बोलूं? इसको n बोल देता हूं. ठीक है, इसको n बोल देता हूं. I'm writing it as n. This is n. Now please expand this number according to place value. Please expand this number according to place value. So 1 के बाद 4, 0 and 7. That means it is 1,07,000. I'm writing this equation here. 1,0,0,0,0,7 plus how much? This is 10n. Do you understand this? Do you understand this, what I have written here? This is 1,07,000 plus 10n. Do you understand this? I've just expanded this number according to place value. Okay? I'm not seeing any comment here. Oh. See, it is simple place value. I'm using the term place value. अरे बाबा 1 के बाद कितनी zeros आएंगी? How many places are there after 1? 5 places, right? And 7 तो अकेला ही है, तो combining it becomes 1,07,000. Fine. And this n, ये complete number को I'm writing n, तो इसके बाद तो एक ही place है ना, so it is 10n. Okay. Now this left hand side is to be multiplied with 3. That is the complete left hand side. ठीक है? Let me create some space here. So now what is the right hand side? Can you write in an equation? Please write this right hand side in terms of an equation. How you can write this part now? It is 100n, right? Because after n there are 2 digits available. So it is 100n plus 71. Yes or no? Please see this. We are almost done. Saroni Verma ji, many of you are asking how 10, how 10, how 10. So bhaiyo behno, listen carefully. If it is 2-digit number A, B, how do you write this? Can you expand it according to place value? Hi, yes, Saloni Verma, I am answering you only. Arey baba, idhar batao mujhe. A, B, it is a 2-digit number. How do you expand this number? This is 1's place value. This is 10's place value, isn't it? Is it A plus B? It is not A plus B. It is how much? Saloni, how 10 and you have typed too many times. Answer karo bhai isko bhi. Yes, 10A plus B, good. Yes or no? ठीक है ना? How do you go to know कि 10A करना है? Why not 10B? Because A के बाद एक digit और है ना? So exactly same way here also. So after n I had one more digit. So it is 10n plus 7. And exactly same way it is 100n plus 71. Now just equate this equation. Just simplify this equation. Exactly. Gandalf the White. Certainly. It is helpful for everything. Okay, please expand it. So this is 3 times 1,07,000 क्या बनेगा? 3,21,000. So 3,0,0,021 plus 30n equals 100n plus 71. So 100n minus 30, that is 70n equals how much? Now 71 needs to be subtracted here. तो 1 तो सीधा इधर चला जाएगा, 7 इसमें से जाएगा तो क्या बचेगा? What will be the value here? Please subtract and tell me. It will be 29950. Am I right? Please check. Is it okay? Yes, 29950. Perfectly fine. Good. So that is 70 n. Now you can easily calculate the value of n. That is 29950 divided by 70. You can cancel out 0. So on cancelling, you will get 7 4s are 28. 1 is remaining. 7 2s are 14. How much is remaining? 7 4s are 28. 1 is remaining. 7 2s are 14. 5. Then what? 7 8s are. अरे कुछ गड़बड़ कर दिया क्या? और एक 0 था क्या? अच्छा हाँ, there was one more 9 basically. हाँ, there was one more 9 here. So 7 4s are 28. 7 4s are 28. 1 remaining. 7 2s are 14. 5 is remaining. 7 8s are 56. 3 is remaining. 7 5s are 35. Right. So 4285. So the value of n comes out to be 4285, and that's what we wanted to find. 4 plus 2 plus 8 plus 5. That is 19. So basically, there are different ways to answer a question. Alright, there was 3 times 9. I missed that. Is it okay? So that's how the basic point is how to think. And there are various ways to solve a particular question. Okay? Okay, ready for the next one now? Exactly, Shreyan. So that's why I discussed this part. अभी आपको first way easy लग रहा है, but in certain cases first way may not be possible. In that case, this is also a way. It is not too much calculative. It is simpler. I had not to think about the single digits. मुझे सोचना नहीं पड़ा ना सभी digits के बारे में. Although that was not difficult. So it's up to us. Okay, let's move to the next question. Now these are some simple questions. How to convert these decimal numbers in rational form, the fractional form. Please answer it fast. Yes, I'm not advocating any particular method. I'm just discussing how we can think, what are the different ways to think. So in a particular question, what way is better, what way suits you more, that you are to decide. है ना? Yes, here is the next question. Please answer fast. This is an easier question. Charu Datta, is it right? I don't think so. Alright, don't do mistake, Baba, in simple question. See, we can write this number as 0.123. Certainly this 232323, this is a repeating part. So this 23 is in the repeating block, isn't it? So I just need to convert this number in the fractional form or rational form. है ना? So you can make up an equation x equal to this and simplify, or otherwise certainly you know the direct relation also. So denominator will contain how many nines? 2 nines, right? Because there are exactly 2 digits in that denominator. So there will be exactly 2 nines and followed by 1 0. Why? Because there is exactly 1 digit between the decimal and the repeating block. So denominator is 990. Some of you were writing 999. It's not. It's 990. ठीक है ना? Now what about the numerator part? So numerator part के लिए I need to do remove the decimal, remove the bar, right? Complete number, that is 123, and I need to subtract that part of the number which was not under the bar, that is 1 only. ठीक है? So this is the final situation. It is 122 divided by 990. but still it is not the final answer. I need to write it in simplest form. What is the common factor you see here? It's 2, right? Because 122 is 2 times 61. So you can cancel out with 2. So it is 2 times 61 and this comes out to be how much? 495, 4, 2 4s are 8, 2 9s are 18 and 2 5s are 10. So 61 by 495 is your answer. ठीक है ना? I hope it is clear with everyone. Yes, certainly Diksha. It will be here on the YouTube only. You can always check this session again. But you will gain the best benefit by attending it live. Anyway, let's move to the next question. Ready? Okay, here it is. Again, similar question, answer fast. Others, you are going to get good questions. Don't worry. Soumya Ranjan Acharya, apply it here. Then you will understand. I told you in the denominator, I have to have 9s followed by zeros. So number of 9s is dependent on the number of repeating digits, and number of zeros is because of the digits between the repeating block and decimal. Highest Himanshu, certainly we can do like that. We can make an equation and solve. Okay, so let me write it here. So it is basically 0.123. Now this time only 3 is in the bar, isn't it? So only one digit is repeating. Now please tell me, what will be the denominator here? Yeah, certainly only 1 9 would be there because there is only one digit in the repeating block. Is it okay? So those who are not understanding that, listen again. Because in the denominator, in this repeating block, there is only one digit. This 3 is repeating only. So there will be exactly 1 9 in the denominator, and it will be followed by 2 zeros because there are 2 digits outside this repeating block. Right? Between the decimal and the repeating block, there are exactly 2 digits. So there would be 2 zeros at the end. So 900 is the denominator here. Fine. Numerator is complete number, removing the bar and the decimal, it is 123, and subtract the extra number, that is 12. So it is 111 divided by 900. Can you cancel out any common factor here? Yes, it's 3 is a common factor. So 37 by 300. So this is the final answer. Okay. Okay. Before moving further, I'm giving you a question just like the first question we did. Please answer fast. See, are you able to think in a logical manner or not? ABC, ABC, ABC. The sum comes out to be C, C, C. We have to find the value of all the digits. Please do it quickly. A 3-digit number ABC is added 3 times, and the sum is another 3-digit number C, C, C. We have to find out the values, and as always, all same digits have same value and different digits have different value. A is not equal to B, not equal to C. It's given here. All different digits have different values. Yes, Akhil, fraction should always be expressed in the simplest form. Now answer this question. Raviraj, by cancelling out the common factor, both 111 and 900 are divisible by 3 each. Excellent, Aditya Singh. Wonderful, Ritika. Good, Danny, Dhruv. Nice. Okay, can you quickly share what is your thought process? Many of you are getting the right answer in the comments. Can you please suggest what is the thought process? Your answer is correct. How to start? Yes, ABC into 3 is equal to CCC, that's true. So what is the starting point? What is the starting point? It is similar question as we did earlier. Yes, exactly. Finding C first. Thank you, Geet. So finding C first. So first I need to think what is the value of C, so that when it is added 3 times, or basically when C is multiplied with 3, if C is multiplied with 3, if I write like this, ABC multiplied by 3, the result is CCC, isn't it? So what should be the value of C, so that after multiplying with C, the unit digit remains C only? What can be the value of C? What can be the value of C? Yes, we are discussing that part only, but after this I should think about the value of C. So what is the possible value of C? Yes, there is only one possible digit, that C should be 5. Good. C equal to 5 ही possible है. That's true, Shaurya Gautam. Excellent. So C should be 5 only. You can check na. 3 into 1 does not end in 1. 3 into 2 does not end in 2. 3 into 3 does not end in 3. 3 into 4 does not end in 4. 3 into 5 ends in 5. और उसके आगे भी चेक करोगे, you will find there is no other value. ठीक है? Other than 0. Although 3 into 0 also ends in 0, but CCC cannot be equal to 0, 0, 0. ठीक है ना? So only value 5 is possible. Okay, what next? C तो मिल गया, ठीक है, 5. What next? How to proceed further now? We got the value of C as 5. So now it is AB5 multiplied with 3. It ends in 5, 5, 5. Now how to proceed further? What is a good way now? Tony, I told that C could have been 0, but can a 3-digit number when multiplied with 3 result in 0, 0, 0? That's not possible, na? Excellent, Aditya. That was a wonderful point. So to find the value of A and B, we could have proceeded further like that only, but the easiest way now would be 555 divided by 3. So 555 divided by 3, that gives you your answer 185. So this is the required answer. This is the value of ABC. ठीक है ना? So 185 plus 185 plus 185, that ends in 555. Is it fine? Good. Yes, C has to be 5 only. Perfectly. Good. Okay, let's move to the next question now. Now let's talk about the prime numbers. Okay, quickly revise. What do you know about prime numbers? What do you know about prime numbers? Good, Danny. Danny has written a nice thing. Every 3 days number CCC is divisible by 37. So last day should be 5. So 555 37. Good. That's true. Okay, yes, prime numbers, only 2 factors. Good. So 2 factors कौन-कौन से होते हैं? The 2 factors are the 1 and the prime number itself. If P is the prime number, so 1 and the prime number itself. So other than that, there is no other positive integer which divide a prime number completely. ठीक है ना? So remember that whenever you are talking about 2 factors, so remember the 2 factors are the positive integers. Otherwise negative integers भी तो होंगे ना? Okay, let me ask you. How many integers divide the smallest 2-digit prime number? Let me write. How many integers divide the smallest 2-digit prime number? Answer, please. Yes, good. Yes, 4 is the right answer. Excellent. So for that purpose only I gave this question. So whenever you were saying 2 factors, so those 2 factors were 2 positive integers. But when I am saying integers, so it includes the negative integers as well. So that's why there are exactly 4 integers which will divide every prime number. Every prime number. Fine. Okay, what next? What next? 2 nahi hai, Namonil. I just told that. Sweta, it is not 2, it is 4. Exactly good. Shaurya Gautam has given nice example there. Fine. Okay, what about the form of the prime numbers? Prime number किस form के होते हैं? Some of you mentioned that 2 is the only even prime number. That's true. 2 is the only even prime number. All others are odd. All other prime numbers are odd. That's fine. Anything else? What is the form of the prime number? Prime number किस form के होते हैं? This is one part. Anything else? Yeah, 6k plus 1, 6k minus 1. Exactly. But there's one condition with that. Don't forget that. Don't forget that. Yes, except 2 and 3. That's true, Jeet. So all prime numbers which are more than 3, they can be written in the form 6k plus minus 1. That means they are going to be one more or one less than a multiple of 6. ठीक है? So except 2 and 3 or more than 3. ठीक है? Fine. ठीक है, that much is sufficient, I guess. So, अच्छा, simultaneously let's talk about square numbers as well. Do you know the form of square numbers? Square numbers किस form के होते हैं? Square numbers किस form के होते हैं? Yes, vice versa not true. Sure, that's true. Vice versa is not true. Here, vice versa is not true, which means कि every number which is of the form 6k plus 1 or 6k minus 1 is not necessarily a prime. You know many such examples. Okay, I'm asking about square numbers now. Square numbers किस form के होते हैं? They are singular. There are many exceptions. I told that the vice versa is not true. लिख देते हैं, not vice versa. Not vice versa. Okay. Okay, square numbers. About square numbers. I'm not asking about square of prime numbers, Shavik, Mansi. Odd factors, that's true. So square numbers have exactly odd number of factors. Odd number of factors, that's true. It can be 3, it can be 5, it can be 7, any odd number. What else? Yes, exactly, good. So square numbers are of the form 3k or 3k plus 1. 4k plus 2 is wrong, Riddhima. It is going to be 4k or 4k plus 1. Yes, 5k plus minus 1. 1 भी चलेगा, Shashank. Why you are saying except 1? It's 5k plus minus 1. 5k also. ठीक है, so these are some of the important forms of square numbers. A square number when divided by 3, either it is going to be divisible, that means 3k, or it is going to leave remainder 1, that means 3k plus 1. Same way, a square number when divided by 4, either it is going to be divisible if it is an even number, or it will leave a remainder 1. Same way, square number when divided by 5, either it is going to be divisible or it will leave a remainder of plus 1 or minus 1, that is 4. है ना? And there is a nice thing written by Akhil here, p square minus 1 is divisible by 24. Okay, why do you think so, Akhil? ऐसा क्यों? They can be of both forms. Yes, Yash. अरे बहुत सारे forms हैं. अरे बहुत सारे forms हैं, Yash, Shaurya. There are so many. Okay, so but these are the important ones. These are the initial ones. So these are important ones. We should remember them. Let's quickly check that. थोड़ा सोच के बताओ. कोई भी number है. Please tell me here, if there is any number, if you divide by 3, let me write mode 3, right? If you divide by 3, what are the different remainders possible? For any natural number, if you divide by 3, what are the different remainders possible? Quickly, please. हाँ, Shaurya, 7 की बात अभी करते हैं, पहले 3 का बताओ. If you divide any natural number by 3, what are the different remainders possible? 0, 1 or 2, right? 0, 1 or 2. 0, 1 or 2. Yes or no? अरे आप किसी भी नेचुरल नंबर को 3 से डिवाइड करोगे, so these are going to be the different remainders possible, या तो 0 या 1 या 2, है ना? Now we are talking of square number. अब सोच के बताओ, if you are squaring, so what will be the remainder with 3? Let's check. So n का remainder अगर 0 था, तो n square का क्या होगा? It is going to be 0 only. Yes or no? Fine. Same way, if n is giving remainder 1 with 3, so n square का remainder कितना होगा? 1 square, that is also 1 again. Isn't it? Yes or no? I just need to square the individual remainders. Same way, if number n is giving remainder 2, so what will be the remainder when n square is divided by 3? So it will depend on 2 square. 2 square yani ki 4, remainder again is 1. So it confirms that all square numbers when divided by 3 will give remainder 0 or 1 only. So certainly this is the desired format of square numbers, and the same method you can check with other numbers as well, as we have done. Okay? Is it clear, Shaurya and others? Now what does it mean? Suppose if I ask you a question, let's say 33n plus maybe मैं यहाँ पे देता हूँ आपको 8. ठीक है, 33n plus 8. Now question is 33n plus 8, for what value of n, for what natural number n this number becomes a square number? For what natural number n this number is a square number? Please tell me. For what smallest natural number n this number becomes a square number? N is a natural number here. Question is, for what smallest value of n this number will be a perfect square? Please answer fast. For what smallest natural number n this number will be a perfect square? Himanshu Manocha says 2. Bhai, let's check. If you put n equals to 2, 33 into 2 is 66. 66 plus 8 is 74. It's not. Jeet says no value. Akhil says 3. Okay, many of you are saying some value 2, 3, 5. In between I am seeing no value also. Vanchita says no value. Akhil Jain 3. अरे 3 कैसे बोल रहे हो भाई अखिल? If you put 3, तो 33 into n कितना हो गया? 33 into n. This is multiplication. 33 times n, na? So 33 times 3 is 99. 99 plus 8 is 107. It is not a square number. Anirudh, if you take n equals to 1, so 33 plus 8 is 41. It's not a perfect square. It will not give any value. Yes, Jeet, you are true. What you have written is perfectly fine. There is no possible value. Kyun? Because this number when divided by 3, this term is divisible and this will give remainder 2. So this number is of the format 3k plus 2, which cannot be perfect square. Which cannot be perfect square. Is it okay? Certainly, Kaf. Yes. Exactly. So that was the benefit of these points. So we should understand what are the different forms of square numbers. And as I said, these are the few initial forms which are important to remember. Okay. So I'm moving further now. El Dorado, I just discussed what are different forms of square number. We have find out that a square number is going to be of the form 3k or 3k plus 1, which means the number 3k plus 2 cannot be a square number. Isn't it? So only I have used that part. So this number is certainly of the form 3k plus 2. When this number is divided by 3, the remainder obtained is 2. है ना? And that cannot be a possible form for a square numbers. So it confirms कि n की value कुछ भी ले लो, you can take any value of n. This number is never going to be a perfect square. That is the only logic. Yes, exactly, Yash. So again, vice versa is not true there. It's not that every number of this form is a square number. It's similar way, not vice versa. Not vice versa. It's not that every number जो 3 का multiple है square ही होता है. ऐसा थोड़ी ना होता है. Not every number जो 3k है वो square होगा. No. Not every number जो 3k plus 1 है वो square हो. No. But अगर square है, then it must be of either of these forms. Fine. So that is a basic logic. Exactly similar to this prime numbers form. Okay, that's why I talked about the square numbers here, because they were also having similar properties as like prime numbers. Is it okay? This is not a 3-digit number here, Aditya. This is multiplication, 33 times n. This is 33 times n. ठीक है? Okay, I'm moving further now. So here is the question based on prime numbers. Yes, please answer this one. I think Akhil was writing answer this directly here. Akhil, now you have to tell me, how did you get that answer? Jeet, there n was natural number. That's true. If you take n equal to -1 to 33 minus 8 would be 25. That's true. Okay, many of you are getting the answer 24, 24, 24. कैसे? How? Example है iQuanta book में. Good. कैसे? Now tell me the logic. What is the reason? What is the reason? That's true. Answer is 24. But what is the thought process? Remainder should be for perfect square number. मतलब Akshat, I didn't get Akshit. So 24 is the right answer here, but how did you get that? By the way, question was which of the following numbers would this be divisible? Always be divisible. So if this number is going to be divisible by 24, so it is going to be divisible by 6 also. Yes or no? It will be divisible by 6 also. If the number is divisible by 24, that's what you are saying, which is true by the way. So it is divisible by 6 also, isn't it? So the answer should be option 4, that more than one of the above. Is it not? Right? Question is saying with which of the following numbers would p square minus 1 always be divisible? है ना? So if it is going to be divisible by 24, then this is also divisible by 6. So answer would be more than one of the above. Right? But now my question is, how did you get to know 24? How did you get to know 24? 6k plus minus form से आप बोल रहे हो. Okay, that means you are saying कि 6k plus minus 1 put कर लें. Okay, let me check. So अगर आप बोल रहे हो greater than 3 इसने बोला है, so I can put the value of 6 as 6k plus minus 1 square minus 1. ठीक है? Let's open the square. So 36k square and plus minus 12k and plus 1 minus 1. That's 2. Plus 1 minus 1 will be cancelled. From here you can take out 12k common. It is 12k into k plus minus, or this is 3k plus minus 1, right? So 12 से divisible तो आ ही गया. अब बचा 2 से और कहां से आएगा? Now this k and 3k plus minus 1. If k is odd, in that case 3k is also odd, but plus 1 या minus 1 करने से it will become even, right? And reverse अगर करता हूं, if k is even, in that case अभी कुछ भी आ जाए फर्क क्या पड़ता है, तो 2 तो मिल ही जाने वाला है. That means it is certainly divisible by 12. It is certainly divisible by 12 into 2 extra, that is 24. ठीक है ना? सही बात है. Anything else? हाँ, yes, that's a good point here, Anirudh. P plus 1 into P minus 1 will always be divisible by 6. That's true. But not only 6. यहां से आप और चीजें भी कैलकुलेट कर सकते हो. Okay, here let me add one more important thing. Okay, answer this one now. अरे क्या किया मैंने? Okay, answer this one. अगर मैं p के बजाय, let me take any natural number n. So n into n square minus 1 is always divisible by. Now tell me, is always divisible by. Now you have to tell me the answer, and it is given that n is a natural number. For n belonging to natural number, n into n square minus 1 is always divisible by. Now answer this. Now it is just a natural number. I'm not saying it's a prime number. It's any natural number. Now what is your answer? इसको थोड़ा सा वैल्यूज बड़ा कर लें क्या इसको? मे बी इसको मैं ग्रेटर देन 1 बोल देता हूं, बिकॉज एट n इक्वल टू 1 तो 0 बन जाएगा ना. Okay, Aditya is saying 6. N into n square minus 1 is always divisible by. You have to tell the greatest number which will always divide this. Yes, they are saying like it is n minus 1 into n plus 1, that's true, but for different values of n, there can be different answers. I want numerical values. हाँ 2 पक्का है, ये बात सही है, I accept that, but is 2 the largest value? Some of you are writing 6 as well. And by the way, 6 is the right answer. 6 is the right answer. Excellent, Aditya Verma. It is product of consecutive numbers. Product of consecutive numbers. See, n square minus 1 is n minus 1 into n plus 1, as many of you are writing. So this is n minus 1 into n plus 1. ठीक है ना? So it is product of 3 consecutive numbers. मैंने जानबूझ के greater than 1 लिया because if I take n equals to 1 तो 0 बन जाता ना. उस 1 को अवॉइड करने के लिए I have taken to be more than 1. Anyway, so n minus 1, n and n plus 1. Fine. So it is product of 3 consecutive integers. Now, I'm telling that. Listen, Shreyan. So n minus 1 into n plus 1, it is product of 3 consecutive integers. Now please listen and carefully answer me. Out of these 3 consecutive integers, please listen and carefully tell me, how many of these 3 numbers will be divisible by 3? इनमें से कितने numbers होंगे जो 3 से divisible होंगे? Certainly. Will there be any number out of these 3 which will be divisible by 3? Yes, exactly one number. It's okay, Jeet. That's true. There will be exactly one number. Is it necessary that one of them is divisible by 3? Is it necessary that one of them will be divisible by 3? Please tell me. Yes. Why? Because there are 3 consecutive numbers. Every third number is divisible by 3. If you select any 3 consecutive integers, any 3, randomly, any 3 consecutive integers, exactly one of them is divisible by 3. Yes or no? You can take any 3. Exactly एक 3 से divisible होएगा. ठीक है ना? That means this product is going to be divisible by 3 for sure. Fine. What about 2? How many of these numbers will be divisible by 2? How many of these numbers will be divisible by 2? Please tell me. How many of these numbers will be divisible by 2? Yes, it is 1 or 2. एक तो पक्का होगा ही होगा, but 2 भी हो सकते हैं. क्या तीनों 2 से divisible हो सकते हैं क्या? Is it possible that all 3 are divisible by 2? Certainly not. Is it okay? Are you understanding? Because every second number, exactly, Shreya, yeah, good. Every second number is divisible by 2. तो कम से कम एक तो 2 से divisible होगा ही, maybe 2. Right? So whatever is the case, for certainty we can say this product is certainly going to be divisible by 2 also. Right? So this product is certainly divisible by 3 as well as 2, of course, as well as 1. So I can say 3 factorial. ठीक है? So in general the result is product of any n consecutive natural numbers, any n consecutive integers. Why to natural numbers? Any integers. Product of any n consecutive integers is certainly divisible by n factorial. That is the general conclusion. Is it okay? Is it understood? Yes, of course, Shruti. It is true for every number. Why not? Shavik, why it is necessary for pakka se 2 hoga? Shavik, see here. If this n is even number, Shobik, if n is an even number, n minus 1 is odd, n plus 1 will also be odd. Then there is only one number which is even, na? Is it okay? Understood? Shobik, abhi to bataya, baba. If n is even, in that case, can any of the other two numbers be even? No. If this n is even, in that case, n minus 1 is certainly odd, n plus 1 will also be odd. Fine? Okay. Next case. If suppose, everyone please answer this question now. If it is given that n is odd number, now same question, यहाँ पे लिखता हूँ. It is given that for n is an odd number. N is an odd natural number. Now this is certainly divisible by. Now tell me. Now tell me, if n is an odd natural number, in that case this expression will be certainly divisible by. Now think and tell me. What will be the answer now? Not 12. Why you are saying 12, Shashank? Many of you are saying 12. Vipul, Shweta, Paleshwari. Why you are saying 12? If n is odd number, तो दोनों even हो गए हैं, right? So it is certainly divisible by 3, that is true. But now there are two even numbers. So listen carefully. Now it is not 12. Shavik, still it is not 12. Listen everyone carefully. Now it is certainly there are two numbers which are even. Yes or no? Now 24 is the answer, right? Because out of two consecutive even numbers, one will be multiple of 2 and other will be multiple of 4. Between any two consecutive multiples of 2, if you will see, one is a multiple of 2, other is multiple of 4. ठीक है ना? So this number will be divisible by certainly 2 into 3 into 4. That is 24. So in that case, 24 will be the answer. Is it okay? So in the given question which you are discussing, that was the same idea there. Okay? There n was not there, it was only n square minus 1, basically p square minus 1, and p was a prime number, that is an odd number greater than 3, it was mentioned, so it was not equal to 3, तो इन दोनों में से ही कोई 3 का multiple आने वाला है, and दोनों ही even numbers हैं, that means one of them is multiple of 2, other is multiple of 4. So that's how we got this value, that p square minus 1 is divisible by 24. Okay? Is it clear to everyone? Yes. Yes, Haseeb. SKC, sir, what is the difficulty? See, I have explained everything in detail. It was 3 consecutive numbers. So there is certainly one number which is multiple of 3 or divisible by 3. There is certainly one number surely which is divisible by 2 and 1. That's how 3 factorial. I generalize it. If it is a product of n consecutive integers, then also there is exactly one number which is divisible by n. There is at least one number which is divisible by n minus 1 and so on. That's how this product of any n consecutive integers is certainly divisible by n factorial. And we applied the same case here again, giving that n is given as odd. If n is odd, then what is going to happen? So if n is odd, then certainly both of these numbers are even. And when we are having two consecutive even numbers, so one of them is multiple of 2 and other will be multiple of 4. You can write any consecutive even numbers. Okay, if I start with the 2. 2 is the first even natural number. Fine. 2 के बाद अगला क्या होगा? What is the next even natural number? It is 4. Yes, Sharwari, that's a good method. You can substitute the value and get the answer. That's true. It's not true every time, but that will limit your answer, that your answer cannot be more than that. Sharwari, are you getting me? By substituting the minimum value, you are going to limit your answer. Answer cannot be more than that. But will that be the answer? That may not be true. That you need to check. Okay? So after 2, the next even number is 4. What after that? 6. Again 8. Then 10. Then 12. You can take any two consecutive even numbers. You will certainly get to know that one is multiple of 2 and other is multiple of 4. So that's the thing which we use here. So this product is certainly divisible by 2 as well as 4 and also 3. So that's how we got this value 24. Okay. Okay, I'm moving forward now. So enough discussion. So we are solving questions side by side. We are trying to understand the logics also. Okay, let's quickly move to the next part. We want to cover a lot more things. Okay, now for how many numbers n that lie in the range 2 to 100 is n minus 1 factorial divisible by n? Please answer this now. Yash, 4 is divisible by 4, isn't it? And 6 is divisible by 2. What is the difficulty there? हाँ P नहीं था, वही तो मैंने बताया था ना. That is not required, Shaurya Gautam. That's what I said. वहां पे P नहीं था, फिर भी that was the same case because P, the middle number was odd, it is certain, and because of which P minus 1, P plus 1 both became even, and P is a prime number more than 3, so that was not multiple of 3, तो P minus 1 या P plus 1 में से ही कोई 3 का multiple भी था. So 3 भी वहीं से आ गया, 2 भी वहीं से आ गया, 4 भी वहीं से आ गया. So 24 was the answer there. Okay, this one now. For how many numbers n in this range 2 to 100, n minus 1 factorial is divisible by n? It's not 0. Why do you say 0? Okay, let's see how to begin with. What is the thought process to start? We can write the smaller values. We know that n varies from 2 to 100. So n minus 1 factorial is divisible by n. Let's check out. So if I put the values n को अगर 2 लेता हूं तो divisible by 2 किसको होना है? 2 minus 1 factorial यानी कि 1 factorial. तो is 1 factorial divisible by 2? No. Next. Is 2 factorial divisible by 3? No. Next. Is 3 factorial divisible by 4? No. Next. Is 4 factorial divisible by 5? Again no. Next. Is 5 factorial divisible by 6? Yes or no? Is 5 factorial divisible by 6? Yes, it is divisible because 6 is a composite number. It has factors 2 and 3 which are included in 5 factorial. So this is my first number which is a valid case. ठीक है ना? इससे पहले वाले 2, 3, 4, 5 all were invalid. They were not satisfying. Let's proceed further and let's try to analyze what is happening. Let's try to analyze what is happening. 6 factorial, is it divisible by 7? Yes or no? Is 6 factorial divisible by 7? It is not. No. Because 7 is a prime number. It is not contained in 6 factorial. It does not divide. Next, is 7 factorial divisible by 8? Yes or no? Yes, it is divisible because 8 is a composite number. It has got small factors 2 and 4. Both are included in the 7 factorial. So it is divisible, right? I hope it is clear now. Next, if I check 8 factorial, is it divisible by 9? Yes. 9 factorial, it is divisible by 10? Yes. But 10 factorial, is it divisible by 11? No. So basically, whenever you will see a prime number here, that will not be divisible, right? Whenever you see a prime number as the divisor, it is not divisible, not divisible. But other than prime numbers, we have this one extra number 4, which also doesn't satisfy. ठीक है ना? Other than all prime numbers, we have this extra number 4, which also doesn't satisfy. That's it. That's it. So now we can easily calculate. उसके अलावा जितने भी composite numbers होंगे, they will certainly divide that number, right? Let's check further also. 11 factorial is divisible by 12. Yes. 12 is 4 into 3 we can write, or 2 into 6. Same way, 12 factorial, is it divisible by 13? Certainly not, because 13 is a prime number. It is not contained there. I hope it is clear now. Now it is simple counting. Now it is simple counting. So from 2 to 100, how many numbers were there? From 2 to 100, how many numbers are there? It's 99. There are 99 numbers, right? Now, out of these 99 numbers, which numbers are to be discarded? Which numbers are to be discarded? all the prime numbers 13, 11, 7, 5, 3, 2, right? All prime numbers. तो 100 तक कितने prime numbers हैं? There are 25. Fine. And also I need to discard this extra number 4, which is not prime, but it's a composite, but this also doesn't satisfy. So this one more number is to be discarded. So this is your right answer. ठीक है. So 73 it is. Fine. Is it okay? $73 is the right answer. Any confusion? I hope it is clear. Fine. Right, I'm moving further now. So here is the next question. In how many ways can 120 be written as a product of two natural numbers? Now we are turning to the topic of factors. It's factors now. Please be quick. See, you are going to get the best benefit of the session provided you be active participant. Okay, don't just be a spectator. Participate. You can give wrong answer, no problem, but respond and answer. In how many ways can 120 be written as a product of two natural numbers? Fast, please. Okay, Soumyadeep Saha has copy pasted. Written, typed, copy and pasted again and again 4 times. Your one answer is sufficient, everyone. Just type once, it's okay. Okay, I'm seeing everyone is writing 8, 8, 8, 8. How did you get that? How did you get that? क्या करना है? Can anyone suggest? Rugved, Kate, no need to repeat your answer. I told that. Yes, number of factors by 2. Excellent. Excellent. Yes, everyone has done that only. Ordered, unordered hoga, isme, usme confused hai. Why confuse, Yash? You know what is the meaning of ordered? When naming is there is no naming right now. It is just saying in how many ways can 120 be written as product of two natural numbers. That's it. So if you write 120 as 10 into 12 or 12 into 10, that is same thing. That is same thing. That's not a different case. अगर यहां पे ऐसा बोला होता कि 120 equals to A into B, and then tell me how many pairs AB are possible. In that case, AB is 10 or 12 or 12, 10. That would be different. That is called ordered pairs, right? But right now there is no naming. It is just saying two natural numbers. So don't be confused in that part. Yes, that's true. It's total number of factors divided by 2. No totient function here, Shaurya. It's not totient function. It is number of factors by 2. Because 120, as I written here, this 10 is a factor, 12 is a factor, right? So jitne bhi factors honge divided by 2. That's it. So number of factors by 2, that is true. So 120 ke factors aapko nikalna hai. So for that, first you need to do the prime factorization of this number. What is the prime factorization here? This is 15 8s are, that is 2 cube into 3 into 5, right? That is a prime factorization of the number. Fine. So number of factors comes out to be number of factors. How do you calculate? You just increase the power by 1. You just add the 1 with each of the powers and then multiply. That is 3 plus 1 into 1 plus 1 into 1 plus 1. है ना? That is 4 into 2 into 2. That is 16. There are exactly 16 factors, and for 16 factors, you will always get 2 factors whose product is equal to the number, right? So that's why answer is number of factors by 2, which is 16 by 2, that is 8. Because for all of the 16 factors, let's write that. So 1 is a factor and its corresponding partner is 120. So product of these 2 factors, right? Same way then 2 and 60 also makes a pair. Same way 3 and 40, 4 and 30, then what 5 and 24, and your 6 and what is this 20, then what 8 and 15, and finally 10 and 12. That's it. So 1, 2, 3, 4, 5, 6, 7, 8. So even if you don't know how to calculate number of factors, you don't know any formula, still just by basic counting also you can get the answer. That is the beauty of the CAT questions. CAT doesn't ask any question which is dependent on a formula. If you don't know, oh, I didn't know this formula, oh, I didn't remember this formula, it is not needed. It is not needed. You just need to know what is being asked and how to solve it. ठीक है? Okay. हाँ, ये ऐड बार बार आ रही हैं बीच में भी. Anyway, that happens. So, okay, shall we proceed now? Romy Kapoor, can you please explain again? Which part, Romy, you want me to explain? I've just explained the whole portion. So we just need to calculate the number of factors and divide by 2. That is the number of pairs. And what are those pairs? That also we have just listed here. Fine? Okay, Khushi is asking something. Sir, natural numbers तो positive होते हैं ना? हाँ. So why did we divide by 2? अरे लड़की बताया ना अभी. 120 के जितने भी factors हैं, तो उसमें से दो factors का product ही तो करोगी. That's what is question. In how many ways I can write 120 as product of two natural numbers? So how many natural numbers divide 120? It is 16, right? 16 natural numbers divide 120. Fine. And उसमें से दो का product वो बनना चाहिए. So how many pairs are there? Exactly half. Because दो का pair बनाना है ना. और वो दो कौन से होंगे? That is also fixed. As we have just mentioned here. First, last, second last, third last, and so on. That's how we get this answer as 8. Okay. Ria, I have already answered that. You should know the meaning of the word ordered, unordered. Don't be confused in that. Question is never going to use these terms. Ordered, unordered. Question में नहीं आने वाला कभी भी. You need to understand that. Yes, of course. ठीक है? I'm moving further now. Okay, here's the next question. In how many ways can 144 be written as a product of two natural numbers? Again, similar question. Please answer fast. It's again similar question, isn't it? So first step, we need to calculate the prime factorization of this number. What is the prime factorization here? It is 2 power 4 into 3 square, right? And what is the number of factors? That will be 4 plus 1 into 2 plus 1. Yes or no? है ना? So this is 5 into 3, that is 15. So there are 15 factors. Now how to do? What to do here? Yeah, Divya Singla is saying number of factors minus 1 by 2. Minus 1 क्यों कर रही हो? Why not plus 1? Okay, let's try to make the parent understand. 15 में हमें साफ साफ दिखाई दे रहा है कि 7 तो बनेंगे. जो एक बच गया उससे कुछ बनेगा कि नहीं बनेगा? क्यों नहीं बनेगा? बनेगा ना? Yes, it is number of factors plus 1 by 2. If you want to use the formula would be here. Number of factors plus 1 by 2. That is 15 plus 1. 16 by 2, that is 8. And what are those 8 ways? Let's count. Let's see. So what is the first factor? 1 and its corresponding partner 144. Right? Next pair 2 and along with it 72. Fine. Their product is again equal to number. Next 3 and then correspondingly it will be 48. ठीक है ना? Rish, you can get that material then if you are not having. Isn't it? So after that 4 and correspondingly what it will be? 36. Next pair 5 is not a factor Is 6 a factor? Yes. तो 6 का corresponding क्या बनेगा? 24. What next? 7 is not a factor, but 8 is a factor? Yes. So 8 के correspondingly it is 18. Then 9 is a factor? Yes. So corresponding to 9 it is 16. What next? 12. And 12 के correspondingly it is 12 only. So that is also a way, na? So 12 was the middle factor here because there were total 15 number of factors. So the middle factor was 12. But while writing this number as product of two natural numbers, this 12 can also be used with itself. So that will also make a pair. So that's how we are adding that extra 12 here. So number of factors plus 1 by 2. So 8 is the right answer. So if you want to remember the formula, there is no difficulty there. Number of factors by 2 if it is not a perfect square. And when number is a perfect square, in that case, number of factors plus 1 by 2. And that is a basic simple reasoning. Is it okay? Yes, 12 was the common part. Good. Okay, let's quickly move further now. Now that's a good question. Read it carefully and try to answer. I'm giving you 2 minutes for this. Yes, Soumyadeep, here's the next question. Shreyan Malik, अगर A not equal to B होता तो 7 pairs. What was that, Shreyan? I didn't get it. There was no ordered pair, na? Naming was not there. Whenever naming is there, in that case, we need to consider order pair. Otherwise, it's okay. Rish, I already answered that. If you are not having this iQuanta material, you can get it. Or if you have access to any other book, you can use that. No problem. The best resource would be the previous year's question papers. The best resource would be certainly the previous year's question papers. RP, here's a question for you now. 81 is not correct. Abhiram. साक्षी, हाँ, I didn't say कि distinct value होना चाहिए. ठीक है, okay, I got you. कौन बोला था पहले? Yes, I got it. कि आप why you are saying. हाँ, Shreyan, I understood what you are saying. कि product of two different natural numbers बोला होता. In that case, answer would be 7, isn't it? हाँ, I got it. I got it, Shreyan. If question would have asked in how many ways we can write 144 as product of two different natural numbers, in that case 7 pairs. That's true. Okay, for this question, Shashank, Ashish, they are saying answer 10. Charudatta says 28. Okay, here's a reasoning also given by Shashanka that only perfect squared number bulbs will be switched on. Okay, think again. I'm just giving you 1 more minute. Why is it so, Ashish? What is the reason for that? Shashanka, can you explain? What is the reason for that? RP sir, that is not correct. Okay, let's see now. Yes, that's good, Shashanka. Good. Okay, let me read it. It says 100 light bulbs are displayed in a line. By the way, here they are portrayed in a circle. Anyhow, whatever be. So they are numbered from 1 to 100. So basically they are numbered separately, differently. Now each light bulb is turned on and off just by pressing its switch. तो switch को press करने से ही on होता है, उसी को press करने से off होता है. That's a normal practice. So they are all turned off at inception. In the beginning, everyone is in the off position. Fine. Every switch is in the off position. Every bulb as in the off position in the beginning. Okay, so now what happens? 100 traders arrive. There were total 100 bulbs and 100 traders arrive. The first trader comes in and presses the switch of each light bulb from 1 to 100. So initially all were off. What will happen? Please think and tell. When the first trader comes and he presses the switch of every bulb, what will happen? Every bulb will be lightened up, isn't it? Sabhi on ho jayenge, right? Every bulb will be in the on position. And now they are all turned on. It's clearly mentioned here. Now the second trader comes in and presses the switch of the second light bulb, then the fourth, then the sixth, and so on. So basically, second trader is switching which bulbs, which switches, even number position, second wala, fourth wala, sixth wala, and so on, right? So initially all were on already, so now they will become off. So therefore turning them off. So basically he's turning them off. So since all were turned on by the previous trader, fine. Now the third trader comes in and presses the switch of the third, turning it off, then sixth, turning it on, ninth, and so on. So basically third trader is now going to every third switch and altering its position. If it was on, so it is turning it off, or agar off tha to usko on kar raha hai, right? So and so on. So up until the 100th trader presses the switch of the 100th light bulb. तो 100 के 100 लोग सारे पहुंच गए वहां पे, है ना, सारे लोग पहुंच गए. सो सिचुएशन क्या है, क्वेश्चन क्या है कि हाउ मेनी स्विचेस आर स्विच्ड ऑन इन द एंड. तो फाइनली कितने ऑन पोजीशन में हैं, हाउ मेनी स्विचेस आर इन द ऑन पोजीशन फाइनली. अगर स्विच बचेंगे इतनी बार प्रेस होने के बाद, अगर स्विचेस बचेंगे तो हाउ मेनी विल बी इन द ऑन पोजीशन, दैट इज द क्वेश्चन. हाउ टू थिंक नाउ, इट इज बिकमिंग कंफ्यूजिंग, isn't it? The bulb that are touched even number of times, that will get off. Good. Okay. सब on हो गए, सब off हो गए. Okay. See, देखते हैं क्या हो रहा है. Let's see here. So if I think from the point of view of the traders, then it is becoming very confusing, because first trader, second trader, third trader, fourth trader, and so on, so up to 100 traders. Although they are going to less number of bulbs every time, because first trader visited all 100 bulbs, isn't it? Second trader visited 50 bulbs, 50 switches, and then third trader visited how many? 33 switches. Fourth trader visited 25 switches. Fifth trader visited 20 switches, and so on. And 100th trader visited only one switch, like that. But if I'm going to take care about all the traders, it is going to be a difficult task. Let invert the thinking process. Let invert the thinking process. Now please tell me, let's take up any example. If I talk about this switch 100 only, so on the switch 100, switch number 100, now tell me, who is the first person who visited this switch? Who was the first person who visited this switch, switch number 100? Please tell me, who was the first person to visit switch number 100? Yes, fast please, fast. Person number 1, that trader number 1, because trader number 1 has visited every switch, and certainly initially they were on the off position, तो उसने जाके on किया है, right? So he turned the switch on, right? What after next? What after the first trader? Who is the next one to visit switch number 100? What is the next person? Who is the next person? Quickly, please. Second. Good. So now second trader is also going to visit 100, because 100 is divisible by 2. So what he is going to make it? He is going to turn it off. उसने इसको off किया है ना? Let's quickly move. Who is the next visitor to this particular switch? After second trader, who is the next person? क्या third number वाला trader यहाँ पे आया है क्या? No. Fourth आएगा ना पहले श्रेया. Yes, third will not be there, but fourth will come. So fourth इसको on कर देगा. After that, fifth will also come now, because 5 also divide 100. So 5 वाला इसको off कर देगा. What will next? Will sixth person visit it? No, not sixth person, right? So next it will be 10. Then yes, sir, some of you have written the complete list. After 10, it will be 20. 20 you missed. Yes, all factors of 100. Good. So basically all factors of 100, they are visiting this particular switch. So after 10, it would be 20, then 25, then 50, and then 100. ठीक है ना? So basically all factors of hundreds, those traders are visiting this particular switch number. Is it okay? So that's how this topic of factors come into this picture, this storyline. And it's very clear now, as we have already seen, the first person is going to turn it on, then next one off, then on, then off, then on, then off. तो अगर even number of persons आए होते तो finally off होता, और अगर odd number of persons आएंगे तो on होगा, right? So 100 के कितने factors हैं? 1, 2, 3, 4, 5, 6, 7, 8, 9. It is odd number. How do we get to know that a number is going to have odd factors or even factors? Whether it is square number or not, we have already discussed that, right? So because 100 is a square number, it has got odd number of factors. So odd factors का मतलब क्या है? It is going to remain on. It is going to remain on. And that was the question actually. How many switches are switched on in the end? So those who are perfect squares. Now, can you tell me how many are perfect squares till 100? We just need to see that how many switch numbers are perfect squares. So tell me, 100 तक कितने perfect squares हैं? How many perfect squares are there? हाँ शौविक, ये कहां से आएगा दिमाग इतना कैट के पहले आ जाए? बस कैट के पहले अगर आप समझ लेंगे तो कैट में आप सेम क्वेश्चन कर सकते हो. You can discuss all the different variations of it also. But if you are facing it for the first time, then it is certainly almost impossible. Yes, 10 is the right answer. So because 1 square, 2 square, 3 square, 4 square, up to 10 square. So these are 10 perfect squares. So these 10 switch numbers are going to be in the on position finally. Is it okay? Is it clear to everyone? Okay, let me ask you one question here. Can you tell me that how many times in this same situation I'm asking, how many times switch number let's say 20 was turned on? How many times switch number 20 was turned on? Please answer this fast. How many times switch number 20 was turned on? Think carefully and answer. Excellent, Soumyadeep Saha. Good. Wonderful, Shaurya. Riya Kumari, please check again. Shavik Chatterjee, 6 is not correct. Samarth, 6 is not correct. Jeet, no, 6 is not correct. अरे हर बार ऑन थोड़े ना किया भाई, हर बार ऑन थोड़े किया है. 100th one will be on. विनीत, कैसी बातें कर रहे हो भाई? पहले ने ऑन किया, तीसरा पर्सन ऑन करेगा, पांचवा पर्सन ऑन करेगा, नौवां पर्सन ऑन ही तो ना करेगा. Yes, 3 times is the correct answer. Exactly, Harish. Good. 3 times off, 3 times on. Excellent. So that is the thinking process. So as I said you earlier, if you are seeing the question for the first time, certainly it is difficult to think. But once we have discussed it, now you should be able to think all the possible variations, which I have just given you an example of. So I'm talking about the switch number 20. So switch number 20 पे कितने लोग आएंगे? How to get to know? How many traders will visit switch number 20? I just need to calculate the factors. Isn't it? I just need to calculate the factors of 20. So 20 के factors कौन-कौन हैं? Let me write the factors. 1, 2, 4, 5, then what? It is 10 and 20. We could have calculated by doing this prime factorization also. There are 6 factors, right? So all of them are not going to on it. So initially all were off. So पहला on करेगा, फिर off करेगा, है ना? फिर से ऑन होगा and then off and then फिर on and फिर off. So exactly 3 persons will turn it on and other 3 will turn it off. So 3 is the right answer. Okay. Exactly. Yes, true. Is it understood? Okay. ठीक है, let's move to the next question now. Prime numbers will remain on. No, Apurva. Prime numbers on कैसे रहेंगे भाई? Prime numbers are being visited by exactly 2 persons, isn't it? So first person is person number 1 and the second person is that prime number itself. Okay, I'm moving further now. Now here's the next question. Find the product of all the factors. That's an easy question now. That's an easy question. Please answer fast. We have a lot more to cover. Please answer fast. That's an easier question now. We just need to find the product of all the factors. By the way, how do we count product of factors? Do you know how to calculate product of factors? It is simply number raised to power number of factors by 2. है ना? So that's an easier question. Yes, number raised to power number of factors by 2. So now to calculate number of factors, so first step is to do the prime factorization. It is 30030. So what is the prime factorization? I can easily see that it is 10 into 3003. That is 3 into 1001 into 10, which means 10 means 2 into 5, 2, 3, 5, and 1001 is 7, 11, 13. 7, 11, 13. So it is number of factors is 2, 2, 2, 2, 2, 2. So 6 times 2. So 2 into 2 into 2 into 2 into 2 into 2. That is 64. So the answer is simply 30030 raised to power 64 by 2. That is this one. Yes, true. That was a simple question. Exactly. That's true. Okay, let's move further. Next one. How many odd factors of 2880 are there? So again, first step is prime factorization. First step is prime factorization. Please quickly tell me what is the prime factorization of 2880? See, to do it quickly, you should always break it in smaller factors as I did in the last case. So 288, I know it is 144 into 2 into 10. Now 144, I know it is 12 into 12, right? 12 into 12 or 16 into 9. So 16 into 9 into 2 into 1 more 2 into 5, which means 2 power 4, 5 and 6. So 2 power 6, 3 square and 5. So that is a prime factorization for the number, isn't it? Himanshu, we just added 1 to each power. We just add 1 to each of the powers and then multiply the power of the different prime numbers. So in this case, the number of factors comes out to be, but question is how many odd factors it is asking. So odd factors के लिए क्या करना है? Yes, remove the powers of 2 to calculate the number of odd factors. If you are only calculating number of odd factors, so what I need to do? Just remove the even powers. Basically 2 की power 6 में से कुछ भी नहीं लेना, 2 power 0 लेना है. So it is 1 into 3 into 2. That is 6. So this is the right answer. So it is as good as कि 2 power 6 को लेना ही नहीं है, छोड़ दो, सिर्फ इसी के number of factors calculate करने हैं, and the method is same. just increase the power by 1. So basically 2 plus 1, 3, and 1 plus 1, 2. So 3 into 2, it is 6. Or I could have said, as I said, कि 2 की power 0 ही लेनी है बस. There is only one possible power of 2 which I can take. Okay? अच्छा, अगर यहाँ पे odd की बजाय even factors पूछे तो number of even factors. Quickly answer now. Number of even factors. Now please tell me. Yes, Soumyadeep has already answered that. Yes, I have seen that, Soumyadeep. Good. Number of even factors. How to calculate? Now I need to take all the powers of 2 except 2 power 0. Right? So 2 power 1 से लेकर 6 तक. There are 6 possible ways to select a power of 6. But for powers of 3, I can take 0, 1 or 2, all the 3 ways. And for powers of 5 also, all both the 2, 0 and 1. That makes it 36. Yes, exactly. 2 power 0 नहीं लेना. Good. ठीक है, clear? Yes, Riya. Okay, let's move to the next question now. Again, similar question, factors. How many factors of 3600 are multiples of 8? Again, first step, prime factorization. What is the prime factorization of 3600? It is 60 into 60, isn't it? 60 into 60. 60 का मतलब 15 into 4. So 4 मतलब 2 square, तो 2 power 4 into 3 square into 5 square. Fine. Now, how many factors are multiples of 8? Now, think and tell me. Answer. Soumyadeep, you are saying 0. 0 is not correct. Why 0? There will be many factors which are multiple of 8. Yes, sure. Yeah, Gautam, that's true. Good. Yes, that's correct, Tejaswar. Right. Okay, that was by mistake, perhaps. Yes, 18 is the correct answer. Good. Now, this time what we need to do? This time what we need to do? Yes, Shobik, 18 is correct. So, कैसे करना है? Now try to understand. Exactly same way as we did earlier. One way is that कि 2 cube को अलग कर लेते हैं, 8 को हटा देते हैं, या फिर think in that way कि I need to take power of 2 at least to be 3. The power of 2 should be at least 3 so that 2 cube makes it multiple of 8. ठीक है ना? तो power of 2 which I can take right now is 3 or 4. Right? या तो 2 की power 3 या 2 की power 4. So there are exactly 2 ways to take a power of 2, 3 or 4. But for powers of 3, there is no constraint. I can take all the possible powers, 0, 1 or 2. That is 3 ways. Basically for 3 power 0 only we are adding 1 here. Same way here also we will be adding 1 for the 5 power 0. So 5 power 0 or 1 or 2, that makes it again there are 3 possible ways to select a power of 5. So just multiply them. So you will get your answer. So 2 3s are 6, 6 3s are 18. So 18 is the right answer. ठीक है ना? That's also fine, Tejeshwar. That's true. That's not correct. That's not wrong. That's fine. Okay, let's move further. So that was about factors. Now coming to next topic, factorials. Any doubt so far? Any doubt so far? Before we start discussing about factorials, any difficulty, any doubt so far? Yash, even निकालने के लिए we can divide the equation by 2, right? Yes, yes, certainly, Yash, that's true. That's true. Okay, let me ask you one more question. ये जो आप divide by 2, divide by 8 कर रहे हो ना, that is not perfectly all right. That is, उसमें mistakes हो सकती हैं. उसमें mistakes हो सकती हैं. Okay, what I was telling is that in the previous question, when you were calculating, you were saying ki remove 8 or remove divide by 2 or divide by 8. There can be some mistakes. Suppose the question 3600, The number 3600, which was basically how much? This was 2 power 4, 3 square, 5 square, यही था ना, right? 2 power 4, 3 square, 5 square, right? So, if I ask you number of factors of this number which are perfect squares, now how will you do it? I need to calculate the factors which are perfect squares. Perfect square factors. Perfect square factors. Now how will you count? Please tell me. Perfect square factors. Perfect square factors. Yeah, how many perfect squares divide this number completely? In a way, I can ask that. 2 is not correct, Soumyadeep. How many perfect squares divide 3600 completely? Only 2 perfect squares. Nahi bhai. Yes, Prasoon, that's correct. Vipul, good. 12 is correct, right? How are you doing now? Too many ad means our product is good. We are getting good commercials. Isn't it, Gaurav? Okay, how to calculate 12? 12 is the correct answer. Yes, exactly. Even powers. Even powers. Yes, square powers, basically even powers. So that's what I was saying in the previous part also. So in spite of dividing by 8, dividing by 2, that becomes confusing. That may be confusing sometimes. So we need to see that which powers can be used, can be taken in the perfect square number, that particular factor there. So right now I'm looking for perfect square factors. So basically the power of the prime number should be even, right? So in case of powers of 2, I can take 2 power 0 or 2 power 2 or 2 power 4. There are 3 possible ways to select powers of 2. Okay, I'm speaking again. So to make my factor perfect square, I need to take power of each prime number to be even. So for powers of 2, I can take 2 power 0 or 2 power 1 or 2 power 2. Oh, sorry, 2 power 0 or 2 power 2 or 2 power 4. There are 3 possible cases. So there are 3 possible cases to select a power of 2, that is 0, 2 or 4. And for powers of 3, there are 2 ways, 3 power 0 or 3 power 2. Fine. And same way for powers of 5 also, there are 2 ways possible, 5 power 0 or 5 power 2. I just need to multiply that to get my answer, that is 12. So there are exactly 12 factors which are perfect squares and which divide this number completely. ठीक है? अगर यहाँ पे perfect cube पूछा होता तो perfect cube factors. अब बताओ. Now what you will do? Now the powers must be multiple of 3, isn't it? Now the powers must be multiple of 3. So what are the possible powers of 2? 0 or 3. Right? There are 2 possible powers of 2, but for powers of 3, there is only one possible way, that is 3 power 0, and one possible power of 5. So it is 2 only. Is it fine? Yes, exactly. Clear to everyone? Okay, if I say how many factors of this number end in 5? How many factors of this number end in 5? 5 में end करने वाले factors. उसके लिए क्या करना होगा? What is the requirement? What is the requirement for the factors which are ending in 5? What powers of 2 can be taken now? Any constraint? Two power 0 only can be taken now. Because if number is ending in 5, that means number has to be odd. It can't be even, right? Why you are taking 1 5 outside, Prasoon? That will just make the factor multiple of 5. That will not ensure whether it is ending in 5 or not, right? So 2 की power 0 ही ले सकते हैं, because even if you take a single power of 2, that will when it is multiplied with 5, it will make the number ending in 0. So only one power of 2 can be taken, that is 2 power 0. For powers of 3, there is no constraint, and for powers of 5, at least one power must be there. So there are two ways. So answer is 6. There are exactly 6 factors of this number which end in 5. Is it okay? Yes, exactly. Minimum 1 power of 5 and exactly 1 power of 2, that is 2 power 0. Or remove 2, we can say. Yes, that's true. Is it fine? Is it clear? So basically, we need to take care of all the constraints there. Whatever constraints are there, accordingly, we need to choose the particular powers of those prime numbers. Yes, exactly. That's my point, Shaurya. It's counting is better than removing, because while removing, you can sometimes miss the basic constraints. So be careful about what are the constraints and accordingly choose your way. Okay? Okay, good. Now coming to factorials. I hope all of you are familiar with factorials. So while talking of factorials, 0 factorial by default we take it to be 1, and all other factorials, factorials of natural numbers, they are basically product of all natural numbers up to that number. So 1 factorial is 1 only, and 2 factorial is 1 into 2, that is 2, है ना? And 3 factorial is 1 into 2 into 3, that is 6. 4 factorial is how much? 1 into 2 into 3 into 4, that is 24. Same way 5 factorial is 1 into 2 into 3 into 4 into 5, that is 120. Same way 6 factorial equals to 1, 2, 3, 4, 5 up to 6. That comes out to be 720 and so on. Okay, before moving further, here's one question to all of you. Please answer fast. There is a 3-digit number ABC. This is a 3-digit number ABC, and it is given that it is equal to sum of factorials of its digits. ABC is equal to A factorial plus B factorial plus C factorial. Find this number. Find this number. Yes, you need to take at least 1 power of 5 also, isn't it? Okay, answer this question now. This 3-digit number ABC is equal to sum of the factorials of its own digits. Okay, Khushi Agrawal has already given the answer. Nice. Mahi, have you solved it or you have verified Khushi's answer? Yes, that's correct answer. It's 145. So 145, we can easily verify. It's 1 factorial plus 4 factorial plus 5 factorial. 5 factorial is 120. 120 plus 24 makes it 144 plus 1, that is 145. So this is the only such number. Good. Good, Mahi. It's fine. Okay, so basically what was the idea? We were to just see what can be the possible values. So what largest digit can I use here? Obviously, if I use 6 factorial somewhere, so 6 factorial is 720, that means my number would be more than 700. So 7 would also be a digit, but 7 factorial is going to be larger number. So 6 can't be used. And 5 must be used, because if I don't use 5 anywhere, so even if I use all the 3 digits as 4, 4, 4, so 24 plus 24 plus 24 will not be 3 digit number. So 5 to aayega hi aayega, and with 5 if I am checking, so that is 120. So 1 we confirm ho gaya. So now there are 2 possible ways. So it is 15C or 1B5. These are the 2 possible cases, and you can easily verify that only 145 satisfies. Yes, we need to check what we can do. So as I said, so largest digit, what largest digit can I take? First, I negated that the largest digits could be 5 only. more than 5 it is not possible, and 5 must be there, and accordingly we got these two cases, and then you can find out. नहीं पता होना चाहिए पहले से नहीं है, that's the way how to think. Okay, let's move further. Navonil, are you asking something or telling something? Maximum of ABC less than equal to 6. That's true. Good. Yes, that's true, Navonil. Good point. And 6 also I negated by the same logic. 6 also I negated by the same logic. Okay, so in factorials, the topic which we had discussed, which is a part of our quant part here, that is to calculate the highest power of a prime number or any other number also in a factorial number, right? So we call it greatest, what was that? Index of greatest power, right? IGP. So here is a question. What is the highest power of 3 that can divide 20 factorial? I hope you remember that. Please do it fast. How to calculate this highest power of 3 that can divide 20 factorial? We'll continue it for one more hour up to 6. Yes, Gaurav, you can take a 2 minutes break in between. You can pause, no problem. Although video will continue. You want to go for washroom or water or whatever. And Navonil, we need to do practice only. We need to think in the different ways. As I told you in the beginning, there are many questions which can't be categorized in any of the particular category, but they belong to the numbers only. Okay. Okay, I'm seeing the same answers here. Very nice. Please quickly tell me what was the method. I just need to divide this 20 by 3, isn't it? So 20 by 3, it is 6. And again, I'm dividing this 6 by 3, that is 2. That's it. That's it. So this is the answer. Good. It is 6 plus 2, that is 8. So that is the highest power of 3 in this number, right? Okay, can you calculate the highest power of 4 in this number? What is the highest power of 4? Oh, before that, let me ask, what is the highest power of 2? What is the highest power of 2 which divides 20 factorial? What is the highest power of 2? Yes, keep on dividing. Logic yahi tha, Atharv, we are to just divide it continuously. But that should be prime number. 2 ki kya power aayegi? If I divide this 20 by 2, it is 10. Then again divide 10 by 2, it is 5. Again divide 5 by 2, it is 2. I'm taking the only integral part. And again divide 2 by 2, that is 1. That's it. So it is 15 and 3, 18. So 18 is the highest power of 2 which divides this number completely. है ना? Good. What about 18? It is, अरे 17 नहीं है भाई, सौम्यदीप. It is 18. कुछ गड़बड़ किया क्या? 10 plus 5, 15 and 2, 17 and 1. 1 also भाई. It's 18. Okay. What about the highest power of 4? Please tell me. What is the highest power of 4 which will divide this number? Yes, it is 9. Good. It's not 6. खुशी, it is not 6. 4 के लिए अब यही काम नहीं करना है. 4 के लिए अब मुझे 5 plus 1 नहीं बोलना है. That is wrong. So this method is applicable only for primes. Only for primes. ठीक है? But 4 is a composite number. So 4 actually is 2 square. So what I need to do? I need to see how many 2 square is available. So 2 is available 18 times. So 2 is available 18 times, which means 2 square is available 9 times. So 9 is the answer here. ठीक है? That is the highest power of 4 which will divide this number. Is it okay? Yes, this video will be available after 6 p.m. also. Why not? Certainly it will be there. I already answered that, Sandeep. Don't worry, it will be there. Okay, quickly, next part. What is the highest power of 5 which will divide this number? What is the highest power of 5 which will divide this number? Fast, please. Highest power of 5 which will divide 20 factorial completely. Yes, it is 4 only. Yes, 5 4s are 20, that's it. Now this 4 is not further divisible by 5. बिल्कुल ठीक बात है. Highest Navonil. Okay, ठीक है, let's move to the next question now. I hope all this part is revised by this one question. मजा आ गया, सारे numbers के concept resolve हो गए. Good, nice. Okay, I'm moving further. Next question. Find the highest. What is the highest power of 35 that can divide 100 factorial? Now see, 35 is again not a prime number. It is composite. शौर्य 6-8 अपने आप से कर लो. Okay, for 35, what we need to check? I'm seeing different answers here. 4, 16, 16 for 35. How to check that? See, 35 is a composite number, it's not prime. So 35 is 5 into 7. So I need to see how many pairs of 5 and 7 will be formed. Acha, tell me one thing. Do I need to check both 5 and 7 or only any one of them will work? Do I need to check for both 5 and 7? Acha, can you tell me which of them will be available in less quantity? I repeat, which of them will be available in the less quantity? 5 और 7, कौन कम बार मिलेगा, किसकी पावर कम होएगी? Of course 7, right? 7. तो 7 बड़ा नंबर है तो उसकी पावर कम मिलेगी, exactly, right? So only 7 is sufficient. There is no need to check both of them. Only to check 7 is sufficient because 5 उससे ज्यादा ही मिलने वाला है, right? So just calculate the power of 7 available here. So 100 factorial में 7 कितनी बार मिलेगा? Just divide it by 7. So 100 by 7 is 14. Now 14 divided by 7 is 2. That's it. So 16 is the right answer. 16 is the right answer. Yes, we need to look for that one which will be in the less quantity, and among 5 and 7, certainly 7 will be in the less quantity. 5 will be certainly in the more quantity. Isn't it? Yes, 16 is the right answer. Good. Okay, I'm moving further now. प्रियांशु, आप 14 को फिर से डिवाइड करना भूल गए 7 से. चिन्मय 7 कहां से आया? हाँ, ठीक है. Okay, let's move further now. Next question. Similar question. Now this time power of 24. Power of 24. Please calculate. Be careful and answer this. What is the highest power of 24 that can divide 100 factorial? Do it fast. RP is the question level of questions fine. (24 power 32). Good. Navanil, Aditya, yes, that's good answer. Prasoon. चालू तो 33 कैसे आया भाई? कुछ गड़बड़ किया है. Shubham, it's not 38. 32 is right. Yes, El Dorado, that's fine. Okay, see, now 24 is 8 into 3. Basically, it is 2 cube into 3. So, if we are not sure that इनमें से कौन कम quantity में आएगा, then calculate for both. We can calculate for both. So, to calculate the power of 2 cube, I need to calculate the power of 2, right? So, what is the power of 2 available in this number? Just divide this number by 2 continuously. 100 by 2, 50. 50 by 2, 25. 25 by 2, 12. 12 by 2, 6. 6 by 2, 3. 3 by 2, 1. If you add them, it comes out to be how much? So, 6, 3, 9 and 1, 10. 10, 10, 10, 10, 10, 10, 10. 25 plus 12 is 37 plus 10, 47 and 50, 97 it is, right? Which means 2 cube So what is the power of 2 cube available? So 2 cube will be 97 by 3. कितना हो जाएगा? That is 32. एक 2 बच गया, क्या दिक्कत है? Right? So 2 cube की highest power is 32. Fine. And for powers of 3, let's calculate. So divide 100 by 3, that is 33. And plus something, certainly it is going to be more than that. So certainly 32 is the right answer. Fine. 32 is the right answer. Okay. Yes, Mahi, that's correct. 2 cube is enough. So, but as I said, if it is, we are not very sure just by seeing the numbers, we can verify, we can check the both values. Okay. So let's move further to the next question now. Yes, now it is the next topic. How many numbers less than 100 are co-prime to it? That is Euler's totient function now. Co-prime numbers. So how many numbers less than 100 are co-prime to it? Yes. Do you remember? Highest number, it will be more than 33 ना, हमने वहीं छोड़ दिया उसको. Yes, it is 40 now. Good. Soumyadeep, that's correct. Do you remember how to do this? कैसे करते हैं इसको? How to do this? Astha, Suman, which you want me to explain? Which part you want me to explain, Astha? Yes, 40 is the right answer here. Euler की बात कर रहे हैं. Okay, Astha. Okay, so yes, the way is, first I need to see the prime factorization of this number. What are the prime factors available here? It is 2 square into 5 square. So here power is not important. I just need to see what prime factors are there in this number, right? What prime factors are there, right? Yes, that's true, Shaurya. Good. So this number of co-prime numbers that is given by our Euler number. So sometimes we write it as En, or sometimes we use symbol phi also, same thing. So Euler number would be how much? So Euler number for 100, let me write 100. Euler number for 100 would be 100 into 1 minus 1 by 2 into 1 minus 1 by 5, where 2 and 5 are the prime factors of this number. Right? On simplifying this, we can easily tell answer. Astha, you are talking about the previous question, okay? So this is 100 into 1 by 2 into 4 by 5, which gives you 40 as the desired answer. Okay, Astha, in the previous question, we were calculating power of 24. For that, I need to calculate the power of 2 cube and power of 3. That's it. For power of 2 cube, we found it to be 32. कैसे पता लगा? Because of powers of 2. And for powers of 3, it was more than 32. It comes out to be 48 actually. So इन दोनों के कितने पूरे pairs बन जाएंगे? Of course, the less of the two, which is 32. ठीक है ना? That's why 32 was the answer. The less of the two, which is 32. So that was the previous question part. ठीक है? Okay, यश गोयल है, base लेते हैं बस. Base नहीं, इसको prime factor बोलते हैं. They are the prime factors. Okay, fine. Yes. Okay. अच्छा सुनो आपको एक अच्छी बात करते हैं यहाँ पे. If I ask you in this question, how many numbers till 100 are multiple of 5 but not multiple of 2? Akshiti, लिखा है ना Euler वाला part. That's it. This is a Euler वाला part. This is a formula. Remember, if number is P1 power A, P2 power B, P3 power C, and so on, where P1, P2, P3 are different prime factors, then Euler number, or basically number of co-prime numbers less than this number of numbers which are co-prime to n and less than n, it is given by this Euler's formula, and the result is it is n into 1 minus 1 by P1, 1 minus 1 by P2, 1 minus 1 by P3, and so on. So that's why in this case, first I found the prime factorization, that is 2 square, 5 square. Now power is not important. I just need to see these base numbers as somebody was mentioning. So these are prime factors here. So I just need to take care of these prime factors. So this Euler number, or basically number of co-prime numbers, co-prime to 100 and less than 100, is 100 into 1 minus 1 by 2 and 1 minus 1 by 5. On simplifying this, we will find our answer, which is 40. ठीक है? Okay, I asked certain question. I भूल गया क्या पूछा था मैंने. अच्छा, मैंने पूछा था odd multiple of 5. Thank you Diya for reminding. I just asked how many numbers are multiple of 5 but not multiple of 2. So multiple of 2 and multiple of 5 की बात कर रहे हैं. तो 5 का multiple हो, 2 का multiple ना हो. That was my question, right? Okay, when I was finding co-prime numbers, उसका क्या मतलब था? उसका मतलब था number is not multiple of 2, not multiple of 5. यही मतलब था ना? Now understand what is happening. Now understand this logical point here. There is no need to subtract, nothing to do. We can do it very fast. Everyone, please be very careful. We can do it very fast. I have just asked you numbers which are not multiple of 2 but multiple of 5. And when we are counting these co-prime numbers, it was actually which is neither multiple of 2 nor multiple of 5. है ना? तो out of every two numbers, one is multiple of 2, one is not. Yes or no? Yes or no? I am asking you. Out of every two consecutive numbers, one is multiple of 2, one is not. Or I can say half numbers are multiple of 8 and half are not. Fine. Exactly same way, out of every 5 consecutive numbers, one is multiple of 5 and 4 are not. Right? In other words, I can say 1/5 are multiple of 5 and 4/5 are not. So when I need to count the numbers which are not multiple of 2, it is going to be half of the total, right? And which are multiple of 5, that is 1/5 of the total. So that makes it 1/10 of the total. So 1/10 of 100 is 10. Here, when I was asking you, the number is not multiple of 2, half of the numbers. The numbers which are not multiple of 5, that is 4/5 of the total, that makes it 4/10 of the total, which was this part. If I ask you the numbers which are multiple of 2 as well as 5, in that case, it is going to be 1/2 into 1/5, that is again 1/10 of the total. Are you getting it? So if the total numbers are multiple of both of them, that is 10, as in this case 100, so I can directly apply this method. It is 100 into this much, that is 10 numbers. 100 into this much, that is 40. 100 into this much, that is 10 again. Is it understood? Is it understood? And see one more thing, it is not necessary only for numbers from 1 to 100. Any 100 consecutive numbers will do. Any 100 consecutive numbers will do. Let me give you another example. Say if I ask you 2017 से लेकर कहां तक पूछे भाई, 2116 तक. There are 100 numbers, fine. From 2017 to 2116. Question is how many numbers are multiple of 5 but not divisible by 2. Number of numbers that are multiple of 5 but not divisible by 2. See, again there are 100 numbers. I can directly apply the same method. Is it okay? So because there are total 100 numbers, so 1/5 are multiple of 5 and 4/5 are not. So I want multiple of 5. So out of these 100 numbers, 1/5 are multiple of 5 but not multiple of 2. It's into 1/2, that is 10 numbers. Which are those 10 numbers? That no need to find, but we can find that. Is it okay? Understood? That's true for any consecutive natural numbers. Any consecutive natural numbers. Yes, that's a basic thing, Soumya. Okay, let's move further now. Now, next topic is HCF or GCD. Highest common factor or greatest common divisor. That is same thing. How to calculate that? What are the different methods? Remember? Please quickly tell me the names. What are the different methods? What are the different methods to calculate highest common factor? I guess Ritika, that is AP only, of course. But why to elongate the question when you can do it faster? Yes, sure, it does not depend on the start or end. It just depends on the number of terms. Number of terms. Think na, if there are 100 consecutive numbers, so out of every 2 consecutive, 1 is multiple of 2, 1 is not. Out of every 3 consecutive, 1 is multiple of 3, 1 is not, 2 are not, and so on. Okay, so prime factorization was the one method here. Prime factorization. Any other method do you know to calculate HCF? Any other? Yes, long division part. Good. So long division part. Basically long division तो हम करते नहीं हैं, उसकी बजाय हम क्या कर लेते हैं? Subtraction method. Subtraction method. Right? Long division तो हम करते नहीं हैं, but long division is nothing but subtraction only. So by subtraction only we can find out the HCF, isn't it? Sometimes when it is not feasible to do prime factorization, in that case this subtraction method is a better one. Subtraction method is better one. ठीक है? Yes, Anuja, I already answered that. Okay, so prime factorization is the normal method which we use to find out HCF of the numbers, and another method which we just mentioned is long division or basically subtraction method. तो कैसे यूज करते हैं? Let me ask you a good question. I learned this. Okay, ठीक है. Let's see the questions mentioned here first. अच्छा, LCM कैसे निकालते हैं? How to find LCM? How to find LCM? LCM में फिर से वही सेम चीज है, prime factorization method. Prime factorization method. And beside that, we have a relation between LCM and HCF. Yes, I'm giving an example for that subtraction method, Kuldeep. Wait, I was thinking for that only. GCD is greatest common divisor. Yash, greatest common divisor. It is synonymous of HCF only. एक ही बात है वो. So prime factorization is the normal method, and beside that we have a relation between LCM and HCF. LCM into HCF is equal to product of the two numbers. Right? LCM and HCF, the product of two numbers. So if I know the two numbers, I don't want to do the factorization or something, but I know the HCF, so I can calculate LCM like that. ठीक है ना? Okay, let's apply these methods first, and then we shall proceed further. क्या पूछें आपसे? Okay, suppose simple example लेते हैं, tough नहीं लेते. Maybe 60 and 72. These are two numbers. They are easy numbers. I need to calculate the HCF. They are simple numbers. I know that. You can tell the answer very fast. But think in how different ways you can answer this question. How to answer this question? HCF of 60 and 72. What it can be? Guess what is the value here? Answer please. Yes, it is 12. That's true. 12 is the correct answer. But how did you get this value, Soumyadeep? How did you get 22? How did you get 12? You know the table basically. Now 12 5s are 60, 12 6s are 72. Yes, 12 is, yes, that's true. सही बात है. But सोचो मुझे table नहीं आता. So what is the difference method or subtraction method? Now see here. So what I'm saying is this: HCF of these two numbers is same as the HCF of the smaller number and the difference of two numbers. I repeat, ध्यान से बात समझिए. Listen again. Yes, that's true. So HCF of these two numbers is same as the HCF of the smaller number and the difference of two numbers. Fine. That's it. This is the name as long division. Long division में क्या करते हो? यही तो करते हो ना? Yes, Vipul, that's true. Prime factorization is one of the ways, but I want to avoid that. We are just looking for the other method. So this is the method. Now it is clearly visible. Suppose if it is not even clearly visible, so the same method will be continued further. So the HCF of these two numbers will be HCF of the smaller number and the difference of two numbers. Now this 12 can be subtracted from this 60 continuously. How many times? 5 times. The end will be 0 only. So when one of the numbers becomes 0, the other number is our answer. Or if you are able to figure it out here only, that 12 divides both the numbers, from here directly you can say 12 is the answer. ठीक है? Are you getting it? So वो same long division जिसको हम बोलते थे, उसी long division को we are writing in the terms of subtraction. It is same thing. Fine. So this is a good method. Without prime factorization, you can answer it. You can use it very fast. No need to do prime factorization always. Suppose I'm giving one more example. Let's say 1440 1320. What is the HCF of those two numbers? Fast, please. You can do prime factorization, I know that. Plus, find the answer fast. What mode here, Navanil? Yes, this is the method. This is the method actually. Okay, find fast. What is HCF here? What is the HCF here? Fast, please. Yes, 120, correct. It's not 12, 120. See, now these are simple numbers. You can do the prime factorization, but prime factorization will take long time, isn't it? Prime factorization here will take long time. You can easily see that the difference of the two numbers is 120, right? And this smaller number itself is divisible by 120. Yes or no? Yes, that's it. So 120 is the required HCF. So basically, when prime factorization is feasible, in that case also this difference method is better. The subtraction method is better. And there would be many cases when prime factorization is not that easy. Let me give you an example. Okay, 667 and 483. Now find their HCF. 667 and 483. Find the HCF. I'm sure now factorization is not easy part. It's not difficult and it's not easy to find factorization now. Do the factorization now. And that is same thing now, the model. What you are saying as mode now here is that subtraction only. You are doing the difference. You are taking the difference only. और वो long division ही तो हुआ ना, and division actually means subtraction. Yes, 23 is the right answer here, by the way. Yes, 23 is the right answer here. See, factorization, if I do 667, I'm not able to see any factors here, but 483 is certainly divisible by 3. It is certainly divisible by 3, isn't it? Yes, 23 is the right answer, good. See, what I'm saying is, even if I'm using that factorization method, so 483 is divisible by 3, it is 3 into how much? 121, kitna aega? 3 1 the 3 3 6 161, right? 161. Is it okay? यही बनेगा ना? Right? It's fine. Yes, that's true. 3 into 161. Now, what I can do one more thing. I can do one more thing here. Certainly 3 cannot be part of HCF. So remove 3. 3 cannot be part of HCF. So remove 3 directly. What is the problem? That can be done. Can you factorize 161 further? 3 is not going to, 3 doesn't divide this number, so 3 is not going to be part of HCF. I can remove this 3 directly. Okay, I can do the subtraction now, that is one of the ways. Or if I want to avoid subtraction also, can you factorize 161 further? Can you factorize 161 further? It is not divisible by 2 or 3 or 5. Is it divisible by 7? Yes, It is divisible by 7. So 161 is basically 7 into how much? 7 2s are 14 and 2s remaining 23. Okay, is 667 divisible by 7? Please check. We can easily check. 7 9s are 63. 3 is remaining. It's not divisible. So 7 को भी हटाओ तो only 23 बचता है. So let's check out whether it is divisible by 23. And yes, it is. And yes, it is. So if I'm using prime factorization, that's how we can do it. Or otherwise, subtraction method I just mentioned, we just discussed here, that can also be used. So basically, when prime factorization is possible, in that case also subtraction is better. Or when it is not feasible, then subtraction remains the only method. Okay, so these are the different ways we can quickly try to find out LCM or HCF of the numbers. Is it okay? Fine? ठीक है, ओके, तो सब्ट्रैक्शन का एग्जांपल आ गया, एलसीएम एचसीएफ की हमने बात कर ली है, एंड लेट्स प्रोसीड फर्दर टू आंसर द क्वेश्चंस. ओके, हियर इज द वन क्वेश्चन हियर. व्हाट इज द मिनिमम नंबर ऑफ क्यूब्स दैट कैन बी कट फ्रॉम अ क्यूबॉइड ऑफ साइड 14 21 35? प्लीज आंसर फास्ट. हाईएस्ट जल्दी से इसको फिनिश करते हैं, उसके बाद अगला रिमाइंडर्स ही आने वाला है. After that, we are only left with the remainders at that unit digit, last two digit, that part only. Shreyan, we discussed many examples now for subtraction. That was 667 and what was that? 4. क्या लिखा था मैंने? 483, right? So you can do the subtraction. If I do the subtraction, how much it is? It is going to be 7 minus 3, it is 4, and 12 और 16. ठीक है ना? 184. So 184 and 483. Right? 184 and 483. Fine. Now again their difference. So 184, let it be as it is. And 184 can be subtracted here 2 times. That is 368. So 184, if I subtract 2 times here, so 368 will be subtracted. So 386 गया तो बचा 12, 123, 123 minus 8. That will be 115. Fine. So now 115 can be subtracted from here. This is how much? 14 जाएगा 7 to 69 it is. Again, as I said, it is a multiple of 3, so 3 हटा दो, because it is not multiple of 3. It is multiple of 5, this is not, so 5 हटा दो. So if I divide it by 5, so 5 to it is 23. That's confirmed, it is 23. That can be used. Okay. Okay. Eldorado is asking, can we use subtraction method for any number? Of course, why not? Any numbers. ठीक है. So in this question, what is the minimum number of cubes that can be cut from a cuboid of side 14, 21, 35? Answer, you are saying 7. How 7? अरे 7 कैसे? It's not correct. It's not correct. कैसे आया 7? That's a tough question. It's not easy question. It's not easy question. Why are you saying 7? 210 is not correct. 30. Acha, what we need to do? What is the minimum number of cubes? How many minimum number of cubes that can be cut from a cuboid of side 40, 21, 35? So let me draw the diagram. It is something like this. Let's say this is 14. Maybe this is 21. ठीक है? Let's say that is the top face. And height is 35. ऐसा मान लेते हैं. ठीक है ना? This is 35. Fine. So this is a cuboid. From this cuboid, we need to cut cubes and minimum number of cubes. Now mind that it is not mentioned here that they are equal cubes. It is not mentioned here. It is not mentioned here. Right? किसने बोला कि ये इक्वल होने चाहिए? Why you are taking LCM? Why you are taking HCF? No. We want to have the minimum cubes. Okay, tell me, what largest size cube you can cut from here? What is the dimension of the largest cube that you can cut? What is the side length of the largest cube that you can cut from here? Please tell me. Largest side length of the cube that can be cut from this cuboid. Soumyadi, this is the dimension of the cuboid. This is 14 by 21 by 35. है ना? Yes, 14 by 14 by 14. Well, exactly. Yes, surely that's true. So that is the largest dimension would be 14 by 14 by 14. बढ़िया है. हाँ, कट तो करना है ना. अरे कट नहीं करेंगे तो क्यूब कैसे बनेगा? This is cuboid बाबा. Okay, so that's true. 14 by 14 by 14. तो ये 14 तो यहाँ था ही, तो यहाँ पे 14 पे कट कर लिया एक, right? और यहाँ पे कट करेंगे तो ये तो 35 था ना, तो 14 का एक और 14 का एक और भी आ जाएगा 28 तक. Is it fine? It is something like this. Is it not? तो इस तरीके से दो क्यूब्स कट गए, right? There are two cubes cut. Now what is this dimension remaining? 7. है ना? So this is 7 remaining, and vertically this total height is there, and here also what is this dimension? This is also 7, right? With a depth of 14, isn't it? तो ये सारा same dimension बचा है अभी. तो now what is the next largest? What is the dimension of the next largest cube that can be cut from this remaining piece now? Remaining cuboid से maximum किस dimension का cube cut कर सकते हो? Yes, it is 7 by 7 by 7. Good. तो यहां पे 7 by 7 के दो बन जाएंगे और इस हाइट में 4 बन जाएंगे. फिर से यहां पे और 4 बन जाएंगे, राइट? और ये नीचे एक एक और आ जाएगा. That's it. तो नीचे हो गए 6, 8, 2 10, 2 12 और 2 14. There are 14 cubes of dimension 7 by 7 by 7, plus there are 1 and 1, 2 cubes of dimension 14 by 14 by 14. So answer is 16. Minimum 16 cubes can be cut. That is the answer here. Is it okay? अरे भाई मुझे तो कम बनाने हैं ना चारुदत्ता. क्वेश्चन इज मिनिमम नंबर ऑफ क्यूब्स. अगर मैक्सिमम बनाने हो तो यू आर परफेक्टली राइट, 1 by 1 के बना लो. बट वाई लिमिट टू 1? 0.1 के बना लो, और कितने भी कम बना लो. फाइन. So our target was to get the minimum number of cubes. For that purpose only, what we have done, we have tried to cut the largest cubes possible. Is it okay? That's what I said. That's what I said. This is not an easy question. Many of you are answering quickly. Sumit Kalam, if maximum पूछा होता तो 1 into 1 into 1. Why 1 into 1 into 1? Sumit, I told you ना, maximum बनाने हैं तो आपको smallest size का बनाना है. Smallest size किसने बोला integral लेना है? You can take half by half by half, 0.1 by 0.1 by 0.1. There is no limit to that now. ठीक है ना? इसमें HCLCM का कोई फंडा लग सकता है क्या कुलदीप कुमार? कुलदीप कुमार जी, HCF LCM हम तभी यूज करते हैं जब हमें इक्वल साइज का बनाना हो. तो एज आई मेंशन्ड हियर, अगर यहां पे बोला है कि व्हाट इज द मिनिमम नंबर ऑफ इक्वल क्यूब्स दैट कैन बी कट फ्रॉम द क्यूबॉइड, नाउ व्हाट विल यू डू? टेल मी. अगर यहां पे बोला है व्हाट इज द मिनिमम नंबर ऑफ इक्वल क्यूब्स, देन व्हाट विल बी द मेथड? There is no other method for this particular question which we have solved. But if I'm changing the question now, what is the minimum number of equal cubes? Now tell me what will be the dimension of each cube. If I want to have cubes of equal dimension, in that case, to have minimum number of cubes, the largest dimension of each cube would be how much? Yes, that's true, Anirudh. Good. Now it should be the highest common factor of 14, 21 and 35, which is 7. Yes, exactly. It is HCF of the three sides. In that case, you can directly apply that 14 by 21 by 35, that is the total volume, and the volume of each of the smaller cubes now would be 7 by 7 by 7. है ना? So now 7 by 7 by 7 ke equal cubes, that would be the minimum answer now, right? So 7 2s are 14, 7 3s are 21, 7 5s are 35. So 2 into 3 is 6, 6 into 5 30. So now the answer would be 30. Now these are 30 minimum number of equal cubes. Is it okay? But in the original question, this equal word was missing. So for that part, drawing is the only solution. Drawing or visualizing is the only solution. Is it fine? Good. Let's move fast further now. So, okay, another question of HCF. I think you can do it easily. If you wish, you can take a screenshot. You can do it later also. I would prefer to move further to discuss some of the remainders part. Yes, let's do this one question. This is a good question. This one is a good question. Please answer this one. Let the LCM of 1, 2, 3 up to 50 is x. Then find the LCM of numbers up to 55. Do this one. Be quick, please. Now that's very easy question. Don't take much time. And that's a good question. Okay, Charudata says 53x. Good. Yes. Any other views? Kuldeep Kumar also says 53x. Yes, excellent. 53x is the correct answer. And why it is so? Because up to 50, x is the LCM that is given. Now after 50, what is happening? We are extra numbers 51, 52, 53, 54, 55. Now 55 is already a divisor of x because 55 means 5 and 11. So x is also divisible of 5 as well as 11. Same way 54 also is having smaller factors of like 2 and 27. Both are factors already available in x. So this 53 is the only prime number. So that needs to be multiplied. So 53x is the LCM of all the numbers from 1 to 55. So that is correct. Good. Okay. This is again easy question. I'm leaving it. And this one is also easier one. You can solve them later. Okay. Try to answer this one now. How many numbers from 1 to 1000 leaves a remainder of 3 when divided by 3, 5 or 25? That's a good question now. Please answer this one. How many numbers from 1 to 1000 leaves the remainder 3 when divided by 3, 5 or 25? What will be the form of these numbers? Numbers किस form के होंगे? See, I want remainder of 3 with 3. 3 से भी remainder 3 हो, 5 से भी remainder 3 हो, 25 से भी remainder 3 हो. That means number should be of what form? 40 is not correct, 13 is not correct. Arey Baba, number should be of the form. Yes, what is written there? Soumyadeep, 5k plus 3, 25k plus 3. Yes, combine them ना. Combine them. Yes, 75k plus 3. अच्छा 13 सही बोला क्या आपने? is 75. Basically, LCM, a multiple of LCM of 3, 5, and 25 plus 3. That should be the form of the numbers, right? Numbers will be of the form 3 times 5 times 3, 5, 75. LCM of 3, 5, 25 into k plus 3. So what is LCM of 3, 5, and 25? It's not 125, it is 75. Isn't it? It would be 75. So yes, so number should be of the form 75k plus 3. Yes, now count that. Just we need to find out among 1 to 1000, how many numbers are of the form 75k plus 3. That's what we need to calculate. Only that's what we need to calculate. Right? So that you can do easily. Now it's up your choice. AP banana hai, kya banana hai, it's your choice. I think 13 वगैरह कुछ बन जाएगा शायद. हाँ 13 सही था I guess. 13 कई लोगों ने बोला था. See, in every 75 numbers there would be exactly one number. That's fine. In every 75 numbers there would be exactly one number. So first number is 3, then next is 3 plus 75, that is 78, then plus 75 and so on. Right? So in every 75 there is one number. So up to 750 if I talk about, there would be 10 numbers. Up to 750 there are 10 numbers. है ना? सही बात है. So you just need to calculate the number of numbers of this format. कोई नंबर 3 से डिवाइड होगा तो 3 रिमाइंडर कैसे दे सकता है? अरे वो 0 समझ लो यार, that is same thing. Remainder of 3 when divided by 3 means remainder 0 basically. Number 3 का divisible है, multiple है. When I am saying number is of the form 75k plus 3, this number is divisible by 3, isn't it? अरे श्रेया, डिवाइड बाय 3 करने पर रिमाइंडर 3 देने का मतलब डिविजिबल ही हुआ. It's okay. Yes, Ashish, exactly, that's correct. You can directly divide 1000 by 75 also. You will get a near about value. So what is the nearest multiple of 75 near 1000? तो यहां तक 10 multiples हो गए. आगे उसके बाद 3 तो और आई जाएंगे. 3 तो और आई जाएंगे, है ना? 3 और कौन कौन से आ जाएंगे? 750 के बाद प्लस 75 का एक और आ गया, 75 एक और आ गया, 75 एक और आ गया. That makes it 225 basically. 225. Now there are still 25 more numbers remaining, and there will be one more number because my number is yes plus 1. That's true. There will be one more number. So answer would be 14. 13 is not correct. 14 would be the answer. So 10 plus 3, 13, and one more number. So 14 is the right answer. 14 is the right answer. See, my number is 75k plus 3, right? So here you can put the value of k starting from 0 up to 13. You can check 75 into 13 कितना बनेगा? Check. If I put k equals to 0, that number would be 3. This is the first number. If I put k equals to 1, number is 78. And so on. If I put k equals to 13, so 13 5s are 65, 65 plus 3 68 ka 8, 6 carry, and then 13 7s are 91, 91 plus 6 is 978. So that is the last number at k equals to 13. So total 14 numbers are there. So 14 is the right answer. ठीक है, not 13. Okay? Yes. अरे श्रेया, ये काउंट किया ना मैंने, ये रहा. In 75k plus 13, you can put the values of k from 0 to 13. So these are total 14 values. And I have told the exact values also. These are the values. Fine. So 978 is the last number. So total 14 such values. ठीक है? Okay, I'm moving further now. We are running out of time. These are again simple question. Remainders. Remainders, all of you know how to calculate. Let's solve one or two questions before we end. Here's one question. Please read it and then answer. Please read this question and answer. Please read this question and answer fast. I think you are also going to have some practice sessions based on the same topics. So don't worry, you will be solving more questions on numbers in the coming sessions. You are going to have some application sections, practice sessions. Yes, answer this one now. शौविक, एक क्वेश्चन 0 तो ले नहीं सकते ना? क्यों नहीं ले सकते भाई 0? Why can't we take 0? 3 is the smallest number, which when divided by 3 gives remainder 3. Which when divided by 5 gives remainder 3. Which when divided by 25 gives remainder 3. So 3 can be taken, Shobik, why not? And also the range given was from 1 to 1000. Fine, so 3 is in that range only. It can be taken. Yes, of course, Shaurya, it is a revision only. Please answer this question fast before we finish this session. Let me read it. 11 dacoits looted n coins. There are 11 dacoits. They looted n coins from the locker of Thakur and fled towards the Chambal Valley. They decided to spend a night inside a cave as it was dark. At midnight, one of them woke up and thought of running away with all the coins. He picked up the bag, but another dacoit woke up and asked for his share. So they divided the loot in 2 parts, but 1 coin remained. ठीक है, 2 parts में divide करे थे तो एक बच गया. Soon enough, another one woke up, and upon dividing in 3, 2 coins remained. And this kept on happening until in the end all woke up, all matlab 11, and 10 coins remained. Okay, it is again same pattern now. So what is the minimum possible value of n? क्या करना पड़ेगा? This is again your second variety. Remember? So जब आप 2 में divide कर रहे हो तो 1 बच रहा है. That means the number is of the form 2a plus 1 and 3b plus 2 and 4c plus 3 and so on up to 11, जो भी क्या आएगा k, 11k plus 10. So now the difference is same. The difference is minus 1, isn't it? So number किस form का होगा? So this number which must satisfy all this condition, it is going to be of the form LCM of all these values, that is 2, 3, 4 up to 11 minus 1, isn't it? It's going to be a large number. Himanshu, it is going to be a large number. 21 will not satisfy, na? 21 को तो आप 3 parts में break करोगे, dividing into 3, तो 2 coin बचने चाहिए थे ना? It's going to be a large number. Now it is LCM of all these numbers up to 11 minus 1. That will be the answer. ठीक है? So that can be done very easily now. It's going to be a large number. Okay. Unit digit. I hope you remember how to calculate unit digit. I hope all of you remember how to calculate unit digit. That was the pattern of cyclicity. Cyclicity of powers of 4. Right? After every 4th power, unit digit repeats. I hope you remember that if a number ends in 0, 1, 5 or 6, unit digit will remain same. But if a number ends in 4 or 9, then unit digit repeats after every 2 powers. At odd powers and even powers, the unit digits come out to be same. And in the remaining digits, that is 2, 3, 7, 8, the powers repeat after every 4th power. That means if the power is of the form 4k plus 1, we have the unit digit same as that of power 1. Same way, if power of the numbers ending in 2, 3, 7, 8 is of the form 4k plus 2, then unit digit is same as that of that number raised to power 2. Same way for 4k plus 3 and 4k. Okay? So that is the simple pattern here. Yes. So here is one question. Please answer fast. And we shall end it here. Find the unit digit of this number. After this, I will take up any of your doubt if there is any. 12 power 456. Find the unit digit of this number. Yes, answer fast. It's not 2. No, Soumyadeep. We just discussed what we need to check. I need to check the power. Yes, that's correct. Good, Prasoon, Pranshul, Sakshi, good. So I need to check this power. It's 456. So is this 456 divisible by 4? Yes, it is 0 mod 4. If you divide it by 4, it is divisible. So basically power is multiple of 4. That means it is 12 raised to power 4k. Its power is multiple of 4. So unit digit is going to be same as that of 2 power 4, which is 6. So 6 is the right answer. ठीक है ना? Right. Okay. जल्दी से एक क्वेश्चन और कर लें क्या? इसका आंसर वो बता दो. What will be the answer here? What will be the unit digit for this number? It is 6 only. We just discussed that. If a number is ending in 6, it always ends in 6 only. Same way for 5 also, it always ends in 5 only. But now here 4 power odd it is. So it will end in 4. So I just need to multiply this and it is going to end in 0. By the way, it was directly visible. This number is always ending in 5 and we are having even numbers. So directly also we could have said it is going to be ending in 0 for sure. ठीक है ना? Right. These are remainder theorems. You know that Wilson theorem, Fermat's theorem, Chinese remainder theorem, all these theorems you are familiar about. ठीक है, so we shall end it here. बस एक लास्ट क्वेश्चन और कर लेते हैं भाई, टाइम तो हो गया है, but still let's do this last question for the day. I'm certainly ending it here. Just end at this point. Find the remainder when this number is divided by 6. How to go about this? Now here's an important thing. What method can you use here? Can you suggest anything? What method can you use here? So there are various ways to solve this question. But you can take out 2 common, you can use Chinese remainder theorem, you can use Fermat's theorem. There are various ways you can do that. But there is another method which is known as what we call it, pattern method, which we just mentioned in the prior to the slide. It was mentioned here, pattern based remainders. So we are using the idea of pattern here. So how we can solve here? How we can solve? Yes, you can use all these methods, but how to use pattern? Now see, now this is a big power of 2. This is a large power of 2. Suppose अगर ये 2 की power 1 ही होता, can you tell me what will be the remainder when it is divided by 6? 2 power 1 when divided by 6, what is the remainder? It's 2 only. I'm just trying to identify the pattern. Is there some pattern? Let's see. So 2 power 1 gives remainder 2 only. ठीक है ना? If it is 2 power 2, I'm increasing 1 power here. It becomes 4. Remainder with 6 would be 4. Yes or no? Of course, yes. Now think carefully. 2 power 3, what will be the remainder when it is divided by 6? 2 power 3 को अगर आप 6 से divide करोगे, क्या remainder आएगा? What will be the remainder? It's again 2, isn't it? It is 8. 8 को 6 से divide करने पे again 2. And 2 power 4 when you divide it by 6, what will be the remainder? It's again 4. Are you getting any pattern in the remainders? Are you getting any pattern in the remainders so far? Yes, pattern is there. Pattern क्या है? 2, 4, 2, 4, 2, 4, 2, 4. Which means whenever the power is odd, remainder is going to be 2. And whenever power is even, remainder is going to be 4. Is it not? Good. So here the power is odd. So answer would be 2. That's it. So that was the idea of using the pattern in the remainders. ठीक है? Yes, so I shall end it here. So thank you very much. We have tried to cover as many things as possible. Almost all the topics we have touched. And we have tried to discuss many of the new ideas as well. I hope you may have gained a lot from this session. I hope so. We have tried to revise all the things also. है ना? So the things which you know already and the things which you might not be knowing earlier also. So thank you everyone for your wonderful presence till the end of the session. Thank you very much. And all the best to all of you for your further sessions, for your exams now. And keep practicing questions. Thank you. Thank you, Raghavendra. I'm having another class also very soon now. So it's a hectic day for me. What are the things after this, sir? Topic is almost over. There are more questions. There are some more questions also left. But anyway, it's fine. Yes, crash course अलग से होगा. Yes, of course. These are marathon sessions, revision sessions. Crash course will be separate. Don't worry. See, that is a benefit of, I have been associated with iQuanta since around last, I think, how many months? Maybe 7-8 months now. maybe 7-8 months almost. So and I know iQuanta since many years, since its beginning only. I know that because all these were students at that time. All these persons were students at that time, and I know that the whole team at iQuanta, I'm seeing it right now, that is very energetic, very enthusiastic team, and they are putting a lot of effort. So many questions, so many events, so many things are there. So many things are there. So certainly you are going to have so many things repeatedly, revision, so many repetition sessions, so many revision sessions. So take the good benefit, the best benefit out of it. It's up to you now that how much you are able to take it from that, how much you are able to extract from it. So I wish all of you best of luck. Good practice is required. अच्छी practice करो, अच्छे से समझो, and and as you may have observed that I always try to avoid the formula, use of formula and all. It's better to understand the things conceptually. That will certainly be helpful always. है ना? Okay. Swamiti, that was a part of your LCM class. If you have attended that LCM class, you can check out there. ठीक है? Yes, I have another class. Shomik, you are there? Okay. Yes, I need to recharge my mic and all. वो बंद हो जाएंगे भैया. Yes, you can watch this video again. This video will remain here only. So we have discussed most of the questions, and in between I skipped few questions that also you can solve and write your answers in comments afterwards. ठीक है ना? Okay. So thank you finally. So I shall leave this session now. Okay. Thank you everyone. Bye sir from Jeet. What is the meaning of that? JKG? अच्छा, you are Jeet. अच्छा, मुझे लगा आप इंद्रजीत की बात कर रहे हैं. I think Namodil, you are having these sessions every week. Every Saturday you are having these marathon sessions. So next session would be most probably on the next Saturday, right? So all the faculties would be taking the sessions. LRDI session would be there. All quant session, arithmetic, algebra, geometry, modern maths, and verbal also. So all sessions would be there. Because you will be getting the details on YouTube only, and I think in your individual batches as well, you will be getting the information. Okay, bye. Thank you everyone. So I shall take your leave now. Thank you once again. Yes, मिलते हैं 7 बजे.